is one of China's premier research-oriented comprehensive universities, which enjoys multiple disciplines in engineering technology, natural sciences, social sciences, business, and management. Established in 1952, NUAA strives to conduct world-level research and education with an emphasis on aerospace technology. Our curriculum represents a strong capacity among all the universities in China. NUAA offers the widest range of programs of any university in China, with 54 undergraduate programs, 200 postgraduate programs, and 16 postdoctoral stations. With a total of 28,000 full-time students, we have a 2-to-1 ratio of undergraduate to postgraduate students. With an annual research budget of $150 million US, our size and history allows a breadth of research activity that can be matched by few universities in China. We take a coordinated approach through our Research Institute to enable the best minds to work together on exciting new areas of study and discovery. Our faculty are comprised of teachers, researchers, and scientists who are paving the way for solutions to complex global issues impacting our environment, technology, and future. NUAA has 2 campuses located 12 kilometers apart. Our Mingugong campus is situated in the very ruins of the Ming Dynasty Palace, and our Jiangning campus is located in a picturesque university town. Both campuses are easily connected by shuttle bus and metro. NUAA first welcomed international students in 2005. 1,300 students from more than 90 countries are currently pursuing different degrees and non-degree programs at NUAA. Our alumni have gone on to work for different Fortune 500 companies in China and abroad. 5 undergraduate programs that are offered in English include aeronautical engineering, mechanical engineering, electronics and electrical engineering, software engineering and management, and international business. International students can choose various non-degree programs, including our Chinese language program, foundation program, summer innovation projects, and joint research projects with Chinese students. Students at NUAA have access to all the world-class infrastructure one comes to expect from a premier university, including an extensive library and international student dormitory, health services at our hospital, a state-of-the-art sports center with a swimming pool, not to mention supermarkets, canteens, cafes, and much more. Our approach to learning sees students apply their theoretical learning to current world problems. We take great pride in our commitment to our students' academics, as well as co-curricular achievements. Students' activities and achievements include Model United Nations, NUAA Got Talent Show, Fly Your Idea, volunteering activities, cultural festivals, and much more. NUAA is located in Nanjing. The 10 times Chinese capital is one of the very few cities where history, urbanization, and nature can be captured simultaneously in one photograph. Just an hour train ride from Shanghai, Nanjing is a commercial, educational, and cultural center in East China, and the capital of the Jiangsu province. Inspire the world starting at NUAA. Begin your academic journey at one of the best research-oriented universities in China to lead the way to the future. We welcome you to join us at NUAA. Apply now at study@nuaa.org.
Good afternoon, respected professors, dean and vice dean, judges, classmates, and lovely audience, and welcome to the second session of NUA Academic Writing Presentation Competition 2026. I take this opportunity to thank our previous session hosts for guiding us through the earlier presentations. Once again, good afternoon to our respected professors, honorable judges, distinguished guests, fellow students, and everyone joining us today. I'm Melek, and together with my co-host Darren, we'll be accompanying you through the second session, featuring groups 12 through 17.
Thank you, Malak, and hello everyone. My name is Darren. We're delighted to be your host for today's part of the academic writing presentation competition. We hope you have been enjoying the impressive research presented so far, and we're excited to continue with another series of innovative and thought-provoking presentations. And without further ado, let's begin with our first group for this session.
Ladies and gentlemen, let us begin with Group 12, presenting their thesis titled Design Efficiency and Performance Analysis of Electric Propulsion Systems in Aviation. As the aviation industry moves toward a more sustainable future, electric propulsion has emerged as one of the most promising technologies. This research explores how electric propulsion systems perform, how efficient they are, and the challenges they face in transforming modern aviation.
From cleaner skies to smarter engineering, this presentation gives us a glimpse into the next generation of flight. So please, everyone, join me in welcoming Group 12.
Greetings everyone, my name is Sudal Shah and I'm from Nepal. Today I will be presenting on the behalf of Group 12 for our thesis defense. Let me start with sharing our presentation. As you can see, we have decided to choose our topic to be design, efficiency and performance analysis of electric propulsion systems in aviation. As you know, aviation is responsible for a significant amount of global carbon emission. As the industry moves towards cleaner and more sustainable technologies, electric propulsion has become one of the most promising solutions. So, in these presentations, we will explore how electric propulsion systems are designed and how efficiently they are compared with conventional engines, their current performance and major challenges, and what future electric aviation may look like. So let us begin with our members. The first is me, presenter from Nepal. Next is our friend from Palestine. She did her part for the acknowledgements. Next, we have Nathan from DRC. Next, we have Dua from Morocco, Agi from Ghana, and Ryan from Morocco. Okay. So let us watch a video about our team members.
Hello everyone, my name is Mr. Jeremy from Ghana. I'm the team leader and I welcome everyone to listen to our presentation.
Hi, my name is Dia Shairi. I am from Morocco. I am Baptist group leader. I am studying aeronautical engineering.
Hello, my name is Mona Noor. I'm from Palestine and I'm studying aeronautical engineering at the NUAA.
Hello everyone, my name is Kamdaj Nathan and I'm part of Group 12. I'm doing electrical and electronic engineering and I'm from ZRC Congo. Thank you.
Hi there, my name is Sudal Shah and I'm from Nepal. I'm an aeronautical engineering student at here in NUAA.
Hello, my name is Ryan from Morocco. I'm 18 years old. I'm a part of the group 12 and I'm in electrical and aeronautics engineering. I study at UAE.
All right, let's look at how our work has been divided into. So, Ege, our team leader, his contribution is team leadership, challenges and future developments for the report, CV, cover letter, and essay introduction. Next, we have DA, our deputy leader. She did the part for her deputy leadership and for efficiency analysis of report number 1, CV, cover letter, essay, concept, and importance of education. Next is me. I am a member of this team and I did my introduction for report number 1, CV, cover letter, essay, with the education and social development part. Next, we have Mona. She's also a member of our group. She did her part for the fundamentals of electric propulsion systems on the report number 1, CV, cover letter, and for the essay, she did conclusions and recommendations part. Next, we have Nathan. He's also a member of our group, and he did the design electric propulsion systems in the report 1, CV, cover letter, essay, and national and economic development part of the essay. Next, we have Nuaa. She is also a member of our group, and she did the part for the performance of Report 1, CV, cover letter, essay, and personal development for the essay. Next is Ryan. He is also the member of our group, and then he did case study in conclusion and CV, cover letter, and for the essay, he wrote personal development. Let's move forward. This is our table of contents. This is what we will be covering throughout our whole presentation. The first thing we're gonna do is talk about our research thesis. The second thing that we will do is report 1 followed by report 2. And then we have another thing that was assigned by our teacher, which is a combined essay that our group wrote. And then we have resume and curriculum vitae for our each members. And then we have cover letters for our each members too. Next, we will be showcasing our learning outcomes and then our questionnaire results with miscellaneous overview and some expressing gratitude, and we will close this presentation. Okay, so let me begin with our presentation. As I already mentioned that our topic is design efficiency and performance analysis of electric propulsion systems in aviation. So let us begin with the introduction. As you can see, we have prepared in a flow. So let's begin with the background. Aviation has relied on fossil fuel over a century, contributing significantly to greenhouse gas emissions. Electric propulsion has emerged as a promising sustainable alternative, leveraging batteries, fuel cells, or hybrid sources to power electric motors. Next is the problem statement. So we have wrote here, low battery energy density limits range and payload. System integration requires careful thermal safety and weight management. A rigorous analysis of efficiency and performance across operating condition is critically needed. Next is the research gap. Existing literature focuses on individual components, battery, motor, or aircraft design in isolation. No unified framework integrates propulsional design, efficiency evaluation, and performance benchmarking together. Next, we have the research methodology. Our entire research is based on the quantitative method. So we have literature review, architectural analysis, efficiency modeling, performance assessment, and challenges and case studies. Let's talk about our thesis objective. So our major aim is to analyze the design, efficiency, and performance of the electric propulsion systems as sustainable aviations to conventional aircraft propulsion technologies. Our research is based on a quantitative comparison between what we had in the past and what we can make in the present and what is in the future. Alright, next is our objectives. So, we will examine fundamental principles of electric propulsion, identify and analyze major propulsion components. We will evaluate design considerations for efficiency and reliability. We will investigate energy conversion efficiency. We will assess thrust power to weight ratio and endurance. We will compare electric versus the conventional propulsion systems. Let's talk about our scope of the thesis. We will be talking about electric aviation overview and motivation. Next is fundamentals and components of EPS. Next, we have architecture, battery, thermal, and safety design, motor, battery, and power electronics efficiency, thrust, endurance, range, and power to weight ratio, existing electric aircraft and emerging technologies. And we will be talking about challenges, limitations, and future research. Let us begin with our research question and the research statement. Our research question is, how can the design, efficiency, optimization, and performance analysis of electric propulsion systems in aviation contribute to the development of a comprehensive technical framework for evaluating the true environmental credentials? Our research statement is, aviation faces growing pressure to decarbonize. Electric propulsion offers zero in-flight emissions, but it's true. Environmental credentials depend on the electricity source. The research critically evaluates whether electric propulsion genuinely delivers net carbon benefits over conventional combustion propulsion, accounting for the full life cycle energy supply chain. Next, we have the design of electric propulsion systems. We will be going through the system architecture, motor and battery, thermal management, and safety certifications. Next is the fundamental of electric propulsion systems. That is, we have all electric and hybrid electric and turbo electric. So let me give a brief insight about how these three work. So we have three motor types, that is BLDC motor and PMSM motor, induction motor. Each have around efficiency from 90 to 95% and 95 to 98% and 85 to 92% respectively. The BLDC has a medium power and induction motor has a moderate power, but the PMSM power motor type has the highest power density. So the BLDC motor is best used in small UAVs and light aircrafts. The PMSM motor is a medium-large electric aircraft, and the induction motor is best used for cost-sensitive applications. Next, we have a core performance analysis. As you can see, range. We have calculated range on the electric aircrafts and how we can calculate the range with the formula. The formula is battery energy multiplied by efficiency multiplied to the lift to the drag ratio divided by maximum takeoff weight. Next, we have endurance. Endurance, the formula is total energy into efficiency divided by the cruise power consumption. And then we have the power to weight ratio, that is the total rated power divided by full propulsion system weight. So there is a table given here which is a comparative performance, like electric versus hybrid versus conventional. So let us look at this. As you can see here, the full electric aircraft has around 0.2 to 0.6 power to weight ratio. Similarly, hybrid electric has around 0.7 to 1.2 ratio. And then the traditional aero engine has 1.5 to 2.5. This is how we can see that the electric system is more beneficial in the sector of power to weight. Next, we have the energy efficiency. The full electric gives efficiency around 75 to 85%, whereas the traditional aero engine gives the efficiency around 25 to 40% only. The hybrid electric somehow gives efficiency from 65% to 75%. The typical range for full electric aircraft is merely low than the hybrid electric. It is around 35 to 800 kilometers. Saying then, we have 800 to 1500 kilometers for hybrid electric aircraft, and for traditional aero engine, we have 1500 to 3000 kilometers. The endurance, whereas for full electric aircraft is around 0.3 to 0.5, and for hybrid electric aircraft it's from 4 to 8. And then for traditional aero engine, we have from 6 to 12. So electric aircraft has very low noise and vibration, whereas compared to traditional aero engines, but hybrid electric aircraft has a medium noise and vibrations. The main thing that our thesis is focused on is the carbon emission. So the full electric aircraft emits zero carbon, which is very beneficial for the environment. Here, in the hybrid electric, the emission is low, and in the traditional aero engine, there is a high emission of carbon dioxide and nitric oxide. Next, let's watch a video that was prepared by one of our group members for simulating in MATLAB.
Hello everyone, my name is Listo Ajebempa from Ghana, and today I'm going to present you with a MATLAB code that we use to compare the efficiency between the electrical propulsion to the conventional propulsion. So let's take the electrical propulsion. So first, we model the electrical propulsion system, and each component that you see here represents a real energy conversion stage. So when you take the battery as an example, we can clearly see that before a battery can work, you need to convert from chemical energy to electrical energy, and it lost around 0.08 of its energy, giving us efficiency of 0.92. And when we take the motor tube, we can clearly see that one tube converts electrical to mechanical energy, producing an efficiency of 0.96. When we take the controller tube, it has an efficiency of 0.95 because of power regulation losses. And when we take the propeller to, it have an efficiency of 0.85 because it converts mechanical energy to thrust. So let's take the conventional propulsion too. The same thing happened during combustion too. We have some thermal efficiency losses which account for around 0.65, giving efficiency of the combustion to be around 0.35 and the turbine to be 0.9, the transmission to be 0.95, and this formula, that's this one and this one, is used to calculate the overall efficiency of each type of electrical propulsion. So let's run this code and see what will happen. So when you run this code, you can clearly see that the overall propulsion graph, that's efficiency to the individual type of propulsion. The electrical one is relatively higher, that's around 71.3, and this one is 29.9%. So overall, the electrical propulsion is efficient compared to the conventional engine. So welcome back again. So in this simulation, we compare the relationship between input power and thrust output for both electric propulsion system and conventional jet engine. So the objective is to analyze how efficiently each system converts power into useful thrust and how their performance scales with increasing power output. So I set the power, this one, I set it from 0 to 200 kilowatts, and it represents different operating conditions of an aircraft propulsion, that from ideal to high thrust demand. So let's try to run this code and see what we will get. So from our graph, where the blue one is the electric propulsion and the red one is jet, you can see that at the lower pace or at a lower power input, that's 20 kilowatts, it produced a thrust around 9.55, where the jet engine produced around 4.44. So it can be seen that it is easier for the electrical propulsion to gain a momentum at a lower power input, which is suitable for our daily life activities. So this is our final simulation. So in this final simulation, we analyze the mission profile behavior of electric aircraft. That's our case study that we used was the NASA S57. And we compared with the commercial or the conventional one or the traditional aircraft. So unlike our previous simulation that focused on efficiency of thrust, this model focused on how propulsion systems behave across different flight phases. So we define the time from 0 to 10 seconds, and it represents a simplified mission timeline where different flight phases occur at different time interval. So let's try to run this code to see what we will get. So from our graph, it can clearly be seen that the electric aircraft changes its operation during different flight phases. So during takeoff, it actually increases its lift, and during cruise, it reduces its lift, which is suitable for we mankind. So in all, we can clearly see that the electric propulsion is quite efficient compared to the fixed or the conventional one, which has been stayed fixed, that's stay here.
All right, thank you. Now let's move forward to our efficiency analysis for our thesis. So we have the total system efficiency formula to be around efficiency of the battery into the efficiency of the controller and the efficiency of the motor and efficiency of the propeller. So we have the following results. For the battery, the efficiency ranges around 90 to 95%. For the controller, we have the efficiency to be around 91 to 95%. For electric motor, we have efficiency to be from 95 to 98%. And for propeller, the efficiency ranges around 80 to 88%. So let me talk about the key factors affecting efficiency. The first is the operating temperature, then we have material properties, and then we have load matching. Next we have scheduled maintenance, and then we have altitude and humidity. Next is the component aging. Let's move forward to the challenges and future development. for the electric propulsion. The current challenges right now for the electric propulsion is the battery limitations, the infrastructure, and the certifications. Then we have some emerging technologies for future, that is the solid-state batteries, distributed electric propulsion, high-temperature superconducting motors, and then hybrid electric architecture. Alright, let me talk about few case studies and conclusion for our thesis. So the first one is the Pipistrel Velis Electro. It's an EASA certified aircraft. It's a European aircraft, which is the world's first fully type certified all-electric light aircraft is with zero in-flight emissions. Next, we have the NASA X-57 Maxwell. It is a research DEP. It is a 12-motor distributed electric propulsion systems demonstrator, high aspect ratio wing boost lift-to-drag ratio. Next, we have the Aviation Alice. It is a regional 9-passenger aircraft with a composite airframe, twin rear-mounted motors targeting 800 kilometers of range. Next, we have Heart Aerospace EF-30. It is a hybrid 30 passengers aircraft. It is similar to the real-world ATR-42 aircraft. It is a 30-seated hybrid electric aircraft with turbogenerator on SAF and extended endurance versus pure battery, zero emission segments over populated areas. So the conclusion is electric propulsion delivers superior efficiency, low noise and zero in-flight emissions. It is best suited for today's urban, short-range and training aviation. Hybrid electric is the near-term regional transition path. Alright, so now let me talk about our research thesis. These are some pages of our thesis and how we started and how we have our group members and the approval pages and the team leader confirmation. Next, we have the declaration of commitment and signatures, and then here we start our thesis. These are the abstracts in both English and Chinese with our research methodology, and then here we start our thesis. These are the pages for our thesis. We move through, and then we have the importance of aerodynamic design in modern aircraft. This is our report. This is our first report that we made. Here is the 7-member collaborative report with the table of contents. Here we go, and we see our introduction, objectives, methodology, and some figurative analysis of our report. And that's how we end this report. Next, we have our second report. The topic of our second report was noise reduction and thrust optimization of electro-aerodynamic propulsion for silent drones. Here we have our report, this made by another member. Next, we have another report. And then now we have the academic essay that we wrote in a collaboration. Here is the topic was the role of education in personal and social development. Here we have our essay and references. Next, we have the professional profiles for Group 12. Here we have our CV for our team leader. Next, we have our CV for our deputy team leader. And then we have the CV for our members. And then one more time, we have CV for our members. Next is the professional profiles for Group 12, that is the cover letters. So let me explain this in brief on how our team has been doing here. Our team leader, he is more focused on strategic and future, and one of our members is engineering focused. Another is performance driven, another one is organized and thorough, another is analytical and detail oriented, another one is analytical and curious, another is creative and collaborative. Here we have our cover letters for our different team members. Okay, thank you. And then now we have the questionnaire results that we did on the first few weeks of our course. This is the summary of our group. We took the help of AI and then we shaped this illustrative analysis of our group questionnaire results. Now we have a miscellaneous overview on how our meeting minutes were prepared by our deputy team leader and some social media portfolio. This is our example of one of our team members. And now I will play a video about how we are happy choosing this course and express our gratitude.
I would like to thank our Professor Wallace for providing us this great opportunity to work in a collaborative environment with people from different places of the world. And then, secondly, I would like to express my gratitude towards the efforts that our team kept to make this thesis successful. Thank you so much.
It helped me grow a lot. I learned how to solve problems better, like stay calm when things change and plan my work more clearly. I also get better at listening to others, sharing my ideas, and help me in my.
Through this course, I learned how to work as part of a research team, contribute to a thesis, and improve my academic writing and communication skills. Finally, I would like to sincerely thank Professor Wallace for his guidance, support, and valuable feedback throughout this course. Thank you so much for that.
Academic course has actually helped me a lot. When we started this program, when I heard about thesis, essay, report, it was something very complicated and complex for me. But with the teamwork that the teacher actually taught us, we were able to divide the work within ourselves and we were able to do it on time.
All right, thank you. Now, I would like to express thank you. So, we sincerely thank Professor Wallace for structuring and guiding our group throughout the academic English writing course. We also thank our fellow classmates, peer reviewers, and all the researchers and authors who published work make this thesis possible. Thank you so much.
Wow, thank you so much, Group 12. That was an inspiring presentation on the future of sustainable aviation. We hope you enjoyed it as much as we did. Judges, you may now begin your evaluation. And to our fellow audience members, if you enjoyed the presentation, please cast your vote for Group 12.
Next, we invite Group 13 to present their research titled Feasibility Analysis of a Compact Thorium Molten Salt Reactor for Unlimited Endurance High-Altitude Pseudo-Satellite Platforms. Imagine an aircraft capable of remaining in the sky for months without refueling. This study investigates whether compact thorium molten salt reactors could make that vision a reality for future high-altitude pseudo-satellite platforms.
Combining advanced nuclear technology with aerospace innovation, this research challenges the limits and endurance and performance. Please, everyone, we would like to welcome for Group 13.
Professor Dr. Woolsey Wallace, thank you for giving us the opportunity to present our thesis. My name is Mohammad Suhanur Rahman Suhan and I am the member of this project. Together with my colleagues from the College of Aerospace Engineering at Nanjing University of Aeronautics and Astronautics, we have been working on a comprehensive feasibility analysis of compact thorium molten salt reactor for ultimate endurance HAPS platform. Let me introduce our team. We are Group 13 and we are very excited to present our work today. Our team consists of Omar, the team leader, Zigors and Nasim are the deputy team leaders. Myself, Shuhan, Aya, Ismail and Nasir are the member of our group. We are honored to address such a distinguished audience. Your expertise inspires us and we deeply value your insight and feedback. We extend our heartfelt gratitude to our supervisor, Professor Dr. Lucy Wallace, for his exceptional mentorship. His guidance in academic writing and nuclear engineering sharpened our research. His encouragement and detailed feedback were pivotal We are truly thank him. Now let's start with our title slide showcasing our team and our trophy. This is our team and we have a small introduction video for you.
Hello everyone. Thank you for taking the time to watch this presentation. My name is Omar Brada and I'm from Morocco. I'm currently studying at Najin University of Aerospace and Aeronautics, and my major is electrical and electronic engineering. In our academic writing course, I work in different assignments that help me improve my writing and communication skills. Through this course, I learned how to organize ideas clearly and express them in the proper academic style. Thank you, everybody.
Hi everyone, my name is Aya Najem and I came from Morocco. I'm an international student here in Najin University of Aeronautics and Astronautics, currently studying aeronautical engineering.
Hello, my name is Grzegorz Sośnicki-Rosin. I'm from Poland. I am a first-year student at the Nanjing University of Aeronautics and Astronautics. My major is aeronautical engineering, and I am a deputy leader of the group 13.
Hello everyone, my name is Ismail Ahmed Khan. I'm from Pakistan and it's my first year here at Nanjing University of Aeronautics and Astronautics. I am pursuing my bachelor degree in aeronautical engineering.
Hello everyone, my name is Hassani Nasir, Moroccan, I'm a student electrical engineering.
Hello everyone, my name is Nasser from Morocco. Study in Nuaa. My major is electrical engineering.
Hi, I'm Suhan and I'm from Bangladesh and my major is aeronautical engineering. This course has been an exciting learning journey from cover letter to preparing a final thesis. Thank you so much for watching this video. Moving on the next slide, table of content. For this we have present our thesis. Detailed slide-wise presentation of the thesis content. In the end of the thesis presentation, we will add screenshot of our report, essay, resume, learning outcome questionnaires, and the closing thanks slide. This is our thesis topic, feasibility analysis of a compact thorium molten salt reactor for ultimate endurance high altitude pseudo satellite platforms. And we are group 13. Our course is academic English writing, class of 2025, and our faculty advisor is Professor Dr. Lozie Wallace. Let me begin by the outstanding structure of our presentation. We will start with an introduction to HAPS platform and the energy challenge they face. Then we will cover the fundamentals of nuclear fission and the thorium-uranium fuel cycle. Next, we will examine the evolution of reactor architecture and explain why the molten salt reactor is the only suitable solution. We will then present the lesson learned from historical nuclear accident that is crucial part of our work because it shows that design are dangerous and why. After that, we will present our proposed reactor architecture, discuss passive safety under the flight dynamics. We will then cover power conversion and electric propulsion, present our mass budget and discuss the regulatory and the static context. Finally, we will conclude our findings and recommendations. Moving on the next slide, the abstract. The problem we address in our thesis is twofold. First, current solar battery system fundamentally limit of endurance of HAPS platform. They simply cannot provide the 20 to 100 kilowatts of continuous power required for advanced payload like radar, communication, and electronic warfare system. Second, historical attempt to use soil fuel reactor in aerospace application we have proven catastrophically unsafe as demonstrated by accident like CL1 and Cosmos 9054. Our solution is the thorium molten salt reactor, which we establish as the only variable architecture to enable perpetual stratospheric flight. The TMSR address both the power and the safety challenges. To achieve this, we designed the core as a 1 to 2 megawatt thermal single-fluid thermal spectrum reactor using the fuel salt. For safety, it features an inherited passive freeze plug gravity drain that active within 2 to 5 minutes, along with strong negative reactivity coefficient that ensures stability under flight dynamics. For the thermal we propose a hybrid system combining a liquid droplet radiator with a supercritical carbon dioxide Brighton circle, achieving 25 to 39% thermal efficiency with near zero aerodynamic drag. Our optimized shadow sheltering protects the playout within 8,200 kg total system mass, making it compatible with the last airship and the highest aspect ratio UAVs. Our conclusion is that by resolving the critical vulnerability and the safety failure modes of historical aerospace reactor, the TMSR provide a technically and operationally feasible pathway for the ultimate endurance HAPS platform. Moving on the next slide. What are HAPS and what are they important? High altitude pseudo satellites or HAPS are platforms that operate in the stratosphere between 18 and 25 km above the sea level. Were designed to fill the gap between conventional UAVs and the satellites, providing persistent localized coverage for communication, surveillance, and reconnaissance. Examples of existing platforms include the Airbus Zephyr and BAE system Pasha 35. These platforms are designed for long-duration missions lasting months or even years, and they provide regional coverage for applications such as communication, radar, electronic warfare, and the reconnaissance. The strategic importance of HAPS is that they offer a persistent presence over a specific region, something that satellite cannot provide because they are constantly moving, and something that conventional UAVs cannot provide because they have limited endurance. Going on the next slide, the stratospheric environment challenges. However, the stratospheric environment is extremely challenging. At 20 km altitude, the air density is only 7% of sea level value, just 0.09 kg per cubic meter. The temperature drops minus 56 degrees Celsius, and the pressure is 5.4% of sea level pressure. Stratospheric winds can reach speeds of up to 30 meters per second or more, requiring platform to maintain its position against these winds, a task that requires continuous propulsive power. This extreme condition means any power source for a HAPS platform must be lightweight, reliable, and capable for providing continuous power of the rigorous environmental conditions. Now, moving on the next slide, the energy problem, limitation of photovoltaics. Current HAPS platforms rely on solar power and the batteries, but this system has fundamental limitations. First, the lunar cycle during the 12 to 14-hour stratospheric night, the platform must rely entirely on the batteries. For a 50 kilowatt platform, This means storing approximately 700 kilowatt hours of energy, requiring over 1,750 kilograms of batteries with current lithium sulfuric technology. The second, seasonal and geographic limitation. Solar-powered SAPs are effectively limited to low altitude and the summer operation. They cannot operate in the Arctic during the winter when the continuous supervision is most needed. Third, aerodynamic drag. The massive solar arrays required to generate the sufficient power to create enormous drag, which in turn requires more propulsive power, a negative feedback loop that limits practical power level to about 5 kilowatts. But many valuable payloads, synthetic and aperture radar, electric warfare system, high bandwidth communication 20 to 100 kilowatts. The solar power approach simple cannot deliver this. This is the power gap that our thesis address. Now I will pass to the speaker, our member Aya.
So the nuclear fission delivers 150 million times the energy density of chemical batteries. So 1 kilogram of uranium equals to 43 tons of wood. But raw power is not enough, it has to be flyable, so we evaluated 3 reactor architecture. Only one passed. So now let's compare the reactor architectures. Light water reactors, they are incompatible. They need 150 atmosphere pressure vessels weighing hundreds of tons, far too heavy. Solid fuel also degrades and poisons over time. Traveling wave reactors, conceptually elegant, but they require more hundreds of tons of fuel to sustain the breather wave. This is too large. Let's move now to the molten salt reactors. The only viable option: atmospheric pressure, liquid fuel, passive safety via a gravity-free plug. Lightweight, compact, and aviation compatible. Now let's move to the core chemistry, thorium-uranium cycle. Thorium-232 breaks into thorium-233 protactin-233 with a 27-day half-life. Liquid fluoride salt operates at a near atmospheric pressure and also allows a continuous fission gas removal. Compared to the uranium-plutonium cycle, thorium produces far less long-lived waste, has lower proliferation risk, and enables predictable, autonomous control, cleaner, safer, and more secure. Now let's move to the geopolitical flea proliferation resistance. Here's the game changer. Thorium burden inevitability produces uranium-232, which emits a hard 2.6 megavolt gamma ray. To handle just 5 kilograms for the uranium-233, you need 100 kilograms of lead shielding. That intense radiation makes the material impossible to hide, transport, or weaponize. Without a massive remote equipment, it's self-protecting. And remember from the slide 1, a solid fuel reactor that killed 3 people when a single control route was withdrawn. Solid control routes and precessed water do not belong in the air. And now let's move to the lessons from history. History teaches us why liquid fuel matters. Gioiania 1587, 93 grams of cesium 1137 abundant caused a radiological disaster. And now the criticism, 1957, a chemical explosion released 740 becquerel, containing 23 tons of kilometers. Cosmos 954, 1978, a Soviet nuclear satellite re-entered solar core, fragmented into over than 4,000 pieces. Only 66 kilograms are recovered. The lesson that we can learn is solid cores fragment into unrecoverable orphan sources. Liquid fuel cannot fragment, period. And now let's move to the orphan source. 93 grams, that's all it took to create a crisis in Guyana. If we put reactors in the sky, we must guarantee they cannot become orphan sources. Liquid fuel, chemically stabilized waste, and passive safety are not optional. They are mission critical. So the fission paradigm gives us unprecedented energy density, but only the molten salt reactor with its thorium fuel cycle delivers it safely, securely, and responsibly. Lightweight enough to fly, passive enough to trust, self-protecting enough to deploy anywhere.
For the reactor architecture, we propose a thermal power of 1 to 5 megawatts thermal. The salt is both a fuel and a carrier. The moderator is nuclear graphite, giving the thermal neutron spectrum, and the operating temperature is 600 to 700 degrees Celsius. We scale this from the China's SM-TMSR 400 to our HIPS class reactor. At this reduced scale, neutron leakage is about 15 to 25% of neutrons leak out of the core. To compensate, we use beryllium oxide reflector, higher fuses loading of 10 to 20 kilograms of uranium-233, and an optimized core geometry. The core dimensions are approximately 1 to 1.5 meters in diameter and 1.5 to 2 meters in height. The core assembly mass is 3,000 to 5,000 kilograms. A critical aspect of our design is passive safety. The MSR has a strong negative temperature coefficient of reactivity, typically -3 to -7 ppm per Kelvin. If the reactor heats up, the fuel salt expands, the fuse's density decreases, and reactivity decreases, automatically self-regulating the power output. The safety area arises from the physics, not from active control system. The reactor is inherently stable. The freeze plug is another critical safety feature. If the power is lost, the plug melts within 2 to 5 minutes. The fuel salt then drains by gravity into a subcritical storage tank, ending the chain reaction. Decay heat starts at 6 to 7% of full power immediately after shutdown and drops about 1% after 1 hour. This heat is removed passively through the natural conversion and radiation without requiring any active systems. A concern for any airborne reactor is how flight dynamically affects reactivity. Our analysis shows that climb and descent have only a small effect on neutronic impact. Atmospheric gusts and turbulence could cause slowing of the liquid fuel or flexure of the graphite moderated, but our analysis shows that reactivity problems are less than 1 ppm for typical gas loads. In the case of accidents, during the first 5 minutes, the freeze plug melts, the salt drains to the tank, and decay heat is removed passively during descent. Multilayer honeycomb limits the kinetic energy of the impact. After the impact, the fuel salt solidifies below 460 degrees Celsius into a stable state. Peak rejection at 20 km altitude presents a fundamental challenge. Air density is only 7% of its sea level, which reduces conversion heat transfer to just 15 to 20% of its sea level value. The solution is liquid droplet radiator. The working fluid is projected as a sheet of fine droplets that radiate heat directly to the cold sky with an effective temperature of 200 to 220 kelvins. For power conversion, we selected the supercritical CO2 Brighton cycle. It operates with a carbon dioxide above its critical point of 31.1 degrees Celsius and 7.38 megapascals. The effectivity is 25 to 39% at our operating temperature, and the turbo machine is extremely compact. Our comprehensive mass budget gives a total system mass of approximately 8,210 kilograms. The reactor core is the dominant mass, accounting for 4,000 kilograms. The shadow shield is 1,200 kilograms. The CO2 power conversion system is 800 kilograms. The airframe reinforcement is 700 kilograms. The thermal management system is 500 kilograms. The strategy context is very important. China investments in thorium MSR technology exceeds 12 billion yuan, with additional 45 billion yuan in industrial investments. The 2 megawatts thorium TMSR LF1 in Jiangsu provides is the world's first operation thorium MSR. In November 2025, China achieves world's first thorium to uranium nuclear fuel conversion. I would like to present a video about thorium reactor. Let me conclude by summarizing our main findings. Nuclear fusion is the only physical solution to unlimited endurance HIPS. The thorium MSR is the only nuclear architecture compatible with aviation safety. Terrestrial and orbital accidents decide exactly which designs are fatally flawed. MSR stability and gravity-driven shutdown arrays from fundamental physics, not active machines. Technology feasibility is high, operational feasibility is moderate, but scalable.
Hello everyone, it's Nazi. Research methodology. This slide presents our research methodology, which is predominantly quantitative in nature. The reason for this choice is that engineering feasibility is ultimately a question of numbers. We need to determine whether the power budget, mass budget, thermal loads, and radiation doses fall within acceptable ranges. Our approach consists of three pillars. First, we conducted a systematic literature review and historical case study analysis of nuclear accidents like the SL1, Guania, Kishim, and Cosmos 954. Second, we performed first principles analytical modeling, applying fundamental equations from physics and engineering. The direct equation, the neutron diffusion equation, the Stefan Boltzmann law, and the equation Plum dispersion model to produce concrete numerical estimates. Third, we conducted systems level integration and mass budgeting, quantifying every component of the platform. We also incorporated results from existing computational simulations, Monte Carlo neutron transport calculation from the MSNP and the OpenMS, and thermodynamic cycle optimization from the Chinese TMSR program at the SINAP. We did not perform original simulations ourselves, but we rigorously analyzed and applied results from authoritative sources. To summarize, our methodology is predominantly quantitative because the feasibility of an engineering system is ultimately determined by numbers, not opinions. We use established physical equations and published simulation results to calculate power, mass, efficiency, and dose. And we express our conclusion in numerical terms that can be verified and challenged. This slide presents the structure and scope of our literature review, which spans 4 interconnected bodies of knowledge. First, we reviewed nuclear fission physics and fuel cycles, covering the thorium-uranium cycle, neutron cross-sections, delayed neutron kinetics, and reactivity coefficients. This foundation comes from standard textbooks and recent papers from the Chinese MSR program and the IAEA. Second, we examined reactor architecture evolution from the aircraft reactor experiment and the molten salt reactor experiment to generation 4 concepts, like the traveling wave reactor and the modern Chinese CMSR program. This allowed us to compare architectures against aerospace requirements. Third, we conducted a forensic analysis of historical nuclear accidents, SL1, Guaiania, Kishim, and Cosmos 954, using the classified CIA reports, IAEA documents, and Canadian government records from Operation Morning Light. This analysis was crucial for extracting engineering lessons that directly informed our reactor design. Fourth, we reviewed HAPS platforms and stratospheric environment literature, covering station keeping, low Reynolds number aerodynamics, and thermal management at altitude, drawing from the IAEA publications, IEEE journals, and Chinese aerospace sources. The synthesis of these 4 bodies of literature allowed us to bridge the gap between nuclear engineering and aerospace engineering, a connection that is essential for our thesis but has not been systematically addressed in previous work. Professor, distinguished colleague, thank you for your attention. We believe our work demonstrated that the compact thorium molten salt reactor is technically and operationally feasible for HAPS platforms, fundamentally resolving the failure modes of historical aerospace reactors and establishing a credible developmental pathway for nuclear-powered HAPS platform. We are now ready to answer any questions you may have. This slide presents our academic report on the CG-1000A high bypass turbofan engine, China's first indigenous propulsion system developed for the COMAC C918 narrow-body airliner. The report covers the complete engine architecture, from thermodynamic cycle and compressor aerodynamics to combustor design, turbine cooling, hollow titanium fan blade materials, engineer frame integration, and certification testing. Our findings show that the CG-1000A, with an overall pressure ratio of approximately 14, a bypass ratio exceeding 9 to 1, and a turbine inlet temperature of around 1700 degrees Celsius, achieves competitive performance while reflecting a conservative, operability-focused design philosophy. We identified key technological breakthroughs, notably 3D printed fuel nozzles, 4th-generation single-crystal turbine plates, and domestically mastered hollow titanium fan blade manufacturing, as well as remaining integration and certification challenges. The CG-1000A uses a two-spool directive drive layout with a single-stage fan. 3-stage booster, 10-stage HP compressor, single annular combustor, 2-stage HPT, and 6-stage LPT. It takes off thrust is 125 to 131 kilonewtons. The bypass ratio is over 9 to 1, and the overpressure ratio reaches approximately 40 at takeoff and 50 at climb. The turbine inlet temperature is of 1700 to 1720 degrees Celsius, is 50 to 100 Kelvin higher than the LAP-1C, enabled by fourth generation single crystal superalloy plates with advanced film cooling and thermal barrier coatings. The thrust to weight ratio of approximately 4.5 is about 36% better than the LAP-1C's 3.3, thanks to lightweight hollow titanium fan plates and high temperature capability. However, the target specific fuel consumption of 0.53 pounds per pound force per hour is about 1 to 2% higher than the LAP-1C, primarily due to the lower bypass ratio of conservative 10-stage HP compressor design, which prioritizes surge margin over peak efficiency. The hollow titanium fan blades represent one of the most significant technological achievements of the CG-1008 program. Each blade is manufactured using diffusion bonding and superplastic forming, a process that China mastered independently and announced in December 2017. The blades achieve a hollow ratio of approximately 35.6%, meaning roughly one-third of the potential titanium mass has been removed, resulting in a 40% weight reduction compared to solid titanium blades. The internal wiring girder web architecture provides structural integrity for high cycle fatigue life exceeding 10 million cycles at 380 megapascals and a bird strike containment under FAR 33.76 requirements. The 3D printed fuel nozzles in the single annular combustor enable lean burn combustion, achieving nitric oxide emissions of 0.024 grams per kilogram of fuel, approximately 20% below the LAP-1C and well within the ICAO CAEP 6 regulatory limits. The fourth generation single crystal turbine blades, protected by internal convection, film cooling, and thermal barrier coatings, can survive gas temperatures 600 degrees Celsius above the metal's melting point. The CG-1000A's integration with the C919 airframe has been carefully managed. The fan diameter of 1.95 meters is actually 3 centimeters smaller than the LAP-1C's 1.98 meters. And the engine is 3 centimeters shorter, correcting the common misconception that the engine is larger. The O-deck structure fan coat, manufactured by AVIC Shenyang, increased pylon torsional stiffness by approximately 22% with only a 4 kilogram mass penalty. The pylon incorporates an emergency breakaway fuse pin system using Enconal 718 pins, validated through full-scale sled tests to ensure clone engine separation without wing penetration. The full authority digital engine control communicates with the C919's avionics via an ARINC 664 data bus, minimizing cockpit changes. The engine has accumulated 6,141 hours of extreme condition testing covering 317 airworthiness items, including bird strike, icing, water ingestion, cold start -3 degrees Celsius, and fan blade of containment. CAAC type certification is expected in the second quarter of 2026, with the first C919 fitted with the CG-1000A engines scheduled for delivery in the third quarter. The CG-1000A is technically sound first-generation engine that establishes China as a designer of modern commercial turbofans. Its key strengths is thrust-to-weight ratio, high temperature capability, and low nitric oxide emissions. The remaining gap is approximately 1 to 2% higher fuel consumption compared to the LEAP-1C, which comes from the lower bypass ratio and conservative compressor design. For EACC and COMAC, we recommend developing composite fan blades for a future variant to close the fuel burn gap. We're designing the HP compressor for higher stage loading and pursuing bilateral airworthiness agreements with the ISEAN and the BELT and door countries as a bridge to international markets. For further academic research, we recommend stage-by-stage HP compressor analysis when test data becomes available. Thermal barrier coating, aging studies, low pressure turbine loss analysis, and supply chain risk assessment, the CG-1000A demonstrates that China has achieved a high level of engineering capability in materials, manufacturing, and systems integration, and it provides a strong foundation for future improvements in compressor efficiency, fan weight, and bypass ratio. This slide represents the central problem addressed in our essay, growing gap between technical knowledge and professional competence among university graduates, particularly in engineering and technology fields. While students master formulas, coding, and complex problem solving, many struggle with communication, teamwork, time management, and cultural understanding when they enter the workplace. Employers consistently note this gap. Graduates know that theory but cannot apply it effectively in real-world settings. The essay argues that soft skills should be integrated into the university subjects as an essential part of education, not treated as an optional or secondary. Through evidence-based practice, we demonstrate that skills such as communication, teamwork, adaptability, cultural intelligence, and assertiveness can be systematically developed through active learning methodologies, project-based work, and structured frameworks like Scrum and Kanban. The World Economic Forum in 2025 and the APET accreditation criteria both confirm that employers and educational standards increasingly value these human skills along technical expertise. This slide covers our proposed solution for developing soft skills within existing technical curriculum. Problem-based learning serves as the cornerstone methodology by confronting students with authentic, ill-structured engineering problems. Communication under constraints become essential negotiation, and conflict resolution become unavoidable, and time management and will constraints mirrors industry conditions. Peer assessments with behavioral rubrics, rotating role team projects, and reflective journals from what we call the pedagogical trifecta. Creating a self-reinforcing ecosystem for soft skill development will also address a critical dimension often overlooked: culture. Communication styles differ dramatically across cultures. For example, Polish students tend to be very direct and truth-focused, while students use indirect, polite language where interesting may be problematic. And Chinese students prioritize harmony, face, and relationships, often communicating disagreements through silence rather than a direct confrontation. Without cultural intelligence training, international teams experience confusion, hurt feelings, and project failure. The solution is not to change who people are, but to help them switch communication modes like changing gears in a bicycle. Different styles work in a different cultural context. This final slide addresses practical objections to integration soft skills and provides concrete solutions. First, an overloaded curriculum. Rather than adding separate courses, we recommend integration within existing technical subjects. Soft skills developed through group projects and project management courses without requiring additional credit hours. Second, objective assessment. We use Scrum-derived behavior rubrics with observable metrics such as sprint delivery completion rates, blocker resolution time, and task status updated, combined with anonymous 360 degrees per assessment and individual reflection. Third, cultural fairness. Implement cultural adaptive dual assessments, combining culture-neutral public metrics, velocity, deliverable completion, with private check-ins for high-context students to discuss in-spoken blocker safety. Fourth, faculty training. A concise 3-hour certification pathway introducing Scrum ceremonies, behavior rubrics, and cultural adaptation techniques. With incentive including recognition and accreditation, portfolios, and improved student placement outcomes, our 12-week implementation roadmaps and program summary table demonstrates that integrating soft skills is not a burden on education. It is an investment in brighter graduates who are not only knowledgeable but also capable, responsible, and ready for the real world.
Here is our group report. The topic name is ARO, Thermodynamics and Structural Analysis of the CG-1000A, High Bypass Turbofan, Integration Challenges, and Optimization for the C919 airframe. Here is our group essay. The topic is the importance of including soft skills in university subjects, from evidence-based practices to global competence at the international technical universities. Here is an individual incident report. Here is an investigation report. Here is a feasibility report. Here is the progress report. And this is a trip report.
My name is Ismail Ahmed Khan, and I will be carrying on the presentation from here onwards. So as you can see, this is the meeting report. So every week we had Professor Wallace's class. We used to hold a meeting on that same day at 7 p.m. So every group member had to be present there at that time, and we held it at the CIE office. And in that we used to discuss the agenda and review the task for that week and discuss how to create, like for example, our resume, the cover letter, this thesis, the presentation, and our team leader used to give us one draft like how we have to do that task. And at the end of the meeting, we used to take a photograph of ourselves as a group to include that in the meeting report. So this is the social media post. So this is basically in our midterm, we had a task for our midterm that we had to create social media accounts, 5 social media accounts, TikTok, Instagram, Twitter, Facebook, and we had to write a blog on the Nuaa website. So these are some of the examples of that. We basically had to share our experiences studying and in China, and how has the university been, how's the teaching in the university. So you can see these are some of the examples of that, like TikTok, Instagram, Facebook, and yeah. We had to include pictures of ourselves at the university, showing how beautiful our campus is here at the Jiangning branch. And yes. And this is one of the first tasks I think that Professor Wallace assigned to us was our resume. And that the format was very strict. We had to include our mobile numbers, email, our location, and the profile career objective, what we would like to do, and our past education, where we have studied from high school to university, our skills that we hold, and our languages and our interest and licenses if we have or not. So these are some of the resumes that were created by our team. And then this is the cover letter, and this was also assigned to us. And in this also we had a very strict format. We had to write our name, our location, our mobile number, Gmail, the date we are writing this letter. This is basically a letter for the internship application, because this will be like really beneficial for us after our universities if we want to apply for internship. And yes, this was the format for that. As you can see, these are other examples from our group members. And this is the meeting minutes, as I stated before, that we used to take a picture at the end of all our meetings, and this is that. And this is the team evaluation, that the learning style, the questionnaires that we did, like, can we do this or not? And this is the example of that. And thank you very much. This has been our presentation for Group 13, and thank you.
Throughout this course, I've learned how to write a well-structured thesis, a persuasive cover letter, and also a polished resume. And now I understand how to adapt my tone and contents for different audience. And I feel confident using these documents to present my ideas and myself professionally.
I want to thank our team leader for leading us throughout the entire semester. I want to thank our teacher assistant for helping us with projects and meeting the deadlines. I would like to give my sincere thanks to our professor, Mr. Wallace, for his teaching and knowledge we gained. We experienced first-handedly the difficulties of communication and coordination. Throughout the semester, I have learned many things I have learned how to write an essay, a resume, a cover letter, and thesis. I have learned how to speak in presentations and how to present my works. I have also learned many things from topics I have chosen. They gave me much insight to many different things.
I would like to extend my sincere gratitude to my team and to the team leaders and teacher assistants for their dedication and support throughout this semester. A special thanks go to my teacher who excellently guide us and teach us and help us learn so many new things. Thank you all for your dedication and hard work.
When I first enrolled in this academic English writing course, I thought it would be about grammar, vocabulary, and structure in essays. Simple enough, but I couldn't have been more wrong. This course turned out to be so much more than writing. It was about communication, collaboration, and leadership. Over the past few months, we didn't just write essays. We wrote meeting minutes, brief reports, incident reports, social media posts, resumes, cover letters, team evaluations, and a full thesis. My group focused on the feasibility theory of molten salt reactions for stratospheric HAPS platforms, a complex topic that pushed us to write with clarity and precision. Every document had a different audience and purpose, so we had to adapt and think critically with every word. But the real learning happened outside the documents. It happened in group discussions, peer reviews, and those moments when we had to step up and take responsibility. We learned how to give constructive feedback without hurting feelings. We learned how to receive criticism with personally. We learned how to divide work fairly, hold each other accountable, and push through disagreements to reach something better than any of us could have made alone. That's teamwork, that's leadership, and this course gave us the space to practice both. So today, I want to say thank you. Stronger writers and clearer thinkers. To my group mates, thank you for the trust and share the effort. We didn't always agree, but we always found a way forward. You showed me that leadership isn't about being the loudest. It's about listening, delegating, encouraging, and showing up when it counts. And to this course, thank you for giving us more than a grade. You gave us a toolkit, resumes that open doors, cover letters that tell our story, reports that communicate complex ideas simply, and a thesis we can be proud of. But more than that, you gave us confidence. Confidence to speak up, confidence to take initiative, confidence to write our own narrative, on paper and in life. This wasn't just an English course, it was a course in becoming professional. It taught us that words matter, people matter, and how we bring them together changes everything. Thank you.
From this course, I have learned not only how to write an academic paper, but also how to express my idea with greater clarity and confidence. Your encouragement and support have made a significant difference in my growth. Thank you for being such an inspiring teacher.
I want to just say something to my teacher. Thank you, Mr. Wallace, for your hard work and you helped me to develop my communication and my teamwork. And I want to thank my team leader.
I would like to thank our team leader for how he led us through the entire semester, our teaching assistant for helping us meet the guidelines and help us with the deadlines as well. And moreover, I would like to thank Professor Wallace for how he taught us through the entire semester and made us learn beneficial things for our future. And furthermore, I would like to thank Professor Wallace because all of his class, the way he taught us was really inspiring to us, and it helped us gain immense knowledge for our upcoming future. For example, the thesis, the cover letter, and most importantly, our resume. So thank you, Mr. Wallace.
And finally, I would like to express my big thanks to all the team leaders and all the teaching assistants, and especially my teacher that he did a great work in teaching us a lot of new things. And I would like especially to thank my team leader Omar and also my teaching assistant who have guided us all this semester, and thank you.
An impressive exploration of a bold and innovative concept Thank you to Group 13 for expanding our perspective on future aerospace technologies. To our judges, you may now begin your evaluation, and audience members, don't forget to vote if you enjoyed the presentation of Group 13.
Moving on, we are pleased to invite Group 14 with their thesis titled Impact of the Next Generation of Smart Suspension Systems for Automobiles. From improving passenger comfort to enhancing vehicle stability and safety, smart suspension technology is changing the way we experience road transportation. This research examines how these advanced systems could shape the future of automobiles.
As innovation isn't only just about speed, but it's also about being smarter, safer, and more comfortable journeys. Please give a warm welcome to Group 14.
Respected Professor Lodi Wallace, respected teacher, invited professors, and my dear classmates.
Yeah, give me a moment. I think these people are coming in soon. There is some hitch. Okay, can we invite group 15 if you don't mind? Okay, let's group 15 come, group 14 will come after group 15. Thank you. Can you invite group 15, please?
Alrighty then, everyone. We would now like to invite Group 15 onto the stage, as Group 14 cannot come at this very moment.
Hi everyone, my name is Halim Naji. I'm from Morocco. My major is engineer electric and electronic, and I'm team leader of the group. I have the pleasure to introduce to you my team.
My name is Faisal. I'm from Yemen. My major is electrical engineering automation. I'm the deputy of group 15.
Hi, I'm Ziyad. I'm Moroccan. My major is aeronautical engineering, and I'm from group 15.
Hi, good evening. My name is Saad Naufal. I'm from Bangladesh. My group number is 15. I'm from the group 15, and my major is aeronautics engineering.
Hi everyone, my name is Fatem Saranuri and I'm from Morocco. My major is aeronautical engineering.
Greetings, my name is Ashraf Selsi. I'm from Morocco, and my major is mechanical engineering, and I'm proud to be a member of Group 15.
Good morning, everyone. We are Group 15, and today we will present our academic writing projects for the 2025-2026 academic year. Our presentation includes the main assignments, reports, evidence, and learning outcomes that we completed during this year. Our group consists of 7 members. Halim is the team leader, Faisal is the deputy leader, and Ashraf is the creative leader. Fatima, Zahra, Ziyad, and Nofel and Ryan are the main speakers. Each member contributed the research, writing, organization, and preparation of the final presentation. The work was divided equally according to each member's responsibilities. Every member completed one part of the smart grid theses, one academic report, meeting minutes, and additional tasks such as social media assignments, questionnaires, resumes, and cover letters. This division helped us complete the projects in an organized and cooperative way. Our coursework included 9 main types deliverables. These were the thesis reports, academic reports, and a script about artificial intelligence and privacy, questionnaires, resumes, and cover letters, short reports, meeting minutes, individual learning outcomes, and group learning outcomes. The presentation includes evidence and previews of the documents that we completed. The table of contents of our presentation begins with the member's introduction, work division, and group work evidence. After that, we will present our thesis about smart grid efficiency and show evidence from our academic reports and assignments. We will also cover meeting minutes, management schedule, team evaluation, conclusions, and our individual and group learning outcomes. Now we will start talking about smart grid systems and their efficiency. Our thesis focuses on smart grid systems and their efficiency. Smart grids combines traditional electrical infrastructure with renewable energy, digital communication sensors, batteries, and automated control systems. The main purpose is to improve electrical distribution, reduce energy losses, and create a cleaner and more reliable power network. Smart grid efficiency depends on digital sensing, two-way communication, and automated control. These technologies allow electricity providers to monitor the network in demand or technical problems. However, smart grid also faces several barriers, including high costs, cybersecurity risks, and difficulty of upgrading older infrastructure. The grid under strain. Traditional electricity grids were mainly designed during the 20th century. They normally send electricity in one direction, from large power plants to consumers, with limited information about what is happening across the network. Today, these grids face increasing pressure from growing cities, electricity vehicles, heating systems, and renewable energy sources such as solar and wind. Consumers also expect electricity systems to be more reliable and resistant to failures. Traditional grid versus smart grid. The traditional grid mainly delivers electricity in one direction and depends heavily on manual control. Smart grid are digital meters, sensors, communication systems, and automated control to be existing infrastructure. This transforms the electrical grid from a static system into an adaptive system. It can monitor conditions, exchange information, and respond automatically when demand changes or faults occur. The core smart grid components. Smart meters record electricity consumption frequently and send the information automatically to utility companies. They can also detect outages and possible tampering. Advanced metering infrastructure, or AMI, connects smart meters with communication network and utility data systems. Communication networks carry information across homes, neighborhoods, and wide areas. SCADA systems and control centers collects field data and allow operators to monitor, control, and optimize the electricity network. The renewable energy integration, smart grids make it easier to integrate renewable energy into the power system. Solar energy uses smart inverters to control voltage, while wind energy uses forecasting to manage changing power output. Battery storage helps balance renewable energy fluctuation. Electric vehicles can be changed during periods of low demand, and vehicle-to-grid technology may allow their batteries to support the network. Microgrid combine local energy generation and storage, and they can sometimes operate independently from the main grid. All these technologies depend on reliable metering, communication, and control systems. The efficiency gains, the figure shows some possible efficiency improvements from smart grid technology. Smart grid losses may be reduced to around 8.5% compared with higher losses in conventional grids. Demand response programs can reduce peak electricity demand by approximately 15%. Smart grid 15%. Smart grid projects may also reduce outage duration by around 32%. Although the initial investments can be expensive, the example shown suggests that investments may be recovered over a period of about 8 years. The consumer benefits and engagement. Smart grid give consumers more information and genders control all the electricity use, real-time and data and flexible pricing can help users move their electricity consumption to cheaper peak hours. Automated faults detection improve reliability and reduce the number and duration of power outage. Consumers can also monitor and manage their energy use through smart meters and connected applications. Smart grids also supports rooftop solar energy, electric vehicle charging, demand response programs, and other modern energy systems. The global investment in smart grid technology has increased steadily. This chart shows growth from approximately $42 billion in 2016 to much higher levels in recent years, with an estimated value of around $112 billion by 2025. North America, Europe, and East Asia are leading smart grid adoption. Other regions include South Asia, Latin America, and Africa have low adoption levels because many countries are still prioritizing basic electricity access before advanced automation. Barriers to adoption. One major challenge is cybersecurity. Because smart grid are highly connected, cyber attacks could disrupt the network or even cause physical power outage. Data privacy is another concern about detailed smart meter. Information may reveal household routines and energy use patterns. Interoperability is also difficult because equipment from different companies may not communicate effectively. Finally, smart grid projects require high initial investment, while the financial benefits may take several years to appear. A case study: the due to smart grid test bed in South Korea combined smart meters and solar energy, wind energy, electric vehicles, and dynamic electricity pricing. The project demonstrated the reductions in outage duration and peak electricity demand. The Enel Telerisco project in Italy was one of the earliest large-scale smart metering projects and covered from more than 30 million customers. It mainly focused on metering and helped reduce non-technical electricity losses through better temper detection. These examples show that different smart grid strategies can solve different local problems. Conclusion and the recommendation: smart grid projects should first identify the main local problems such as technical losses, electricity thefts, spark demand, or poor reliability. The selected technology should match the specific needs of the area. Common interoperability standards are necessary so that equipment from different manufacturers can work together. Cybersecurity and privacy protection should also be included from the beginning of the projects. Smart grid should be introduced gradually and through pilot projects before full implementation. Finally, future should collect more real-world data from operation electricity networks to confirm the long-term efficiency benefits. And now I'm gonna let my other teammate to speak about the remaining parts.
This section presents evidence from our 35-page thesis, Smart Grid System and their efficiency. This page shows there's cover, team member responsibility, and equal contributions. Our research examines how smart grid improve efficiency, reliability, and sustainability. Use literature, and case study. This thesis contains 8 chapters supported by figure, table, references, and technology calculations. To introduce compressed traditional one-way grid with smart grids that use digital monitors and two-way communication. The literature review defines smart grid and explain as structure and main focus of the research. This page shows smart grid development region, adoptions, and the main layer of smart grid architecture. These sections explain smart meter, communication network, sensors, and control center. The subject this chapter cover solar, wind, storage, and distribute generation electric devices and microgrids. The chapter show how smart grid reduce electrical loss and help lower peak damage. This section damage reliability, investment costs, economist benefit, and security risk. The case studies compare with usual smart grid project and fuel to store supported by our research methodology. The thesis concluded the smart grid improve performances but face costs, privacy, and security challenges. Those pages present the references and the symbol calculations used in the thesis. Each member completed different section, including and introductions technology, renewable energy, efficiency, challenged, and conclusions. We will move from this thesis to our solid energy report. These slides show evidence from the first part of solar energy report. These sections continue. The report will move technically information about solar energy systems. This page presents another part of the research completed by the group. This section discusses solar energy from an engineering, economist, and environmental representative. This is the final evidence page from our completed solar energy report. The report was divided among the members and cover solid thermal system, photovoltaics, strong grade integration, efficiency, and engineering application. And now I will let you move with my another team member.
This section shows our meeting minutes. It proves that our group discussed that work, divided tasks, and followed the project requirements. And this picture shows our group meetings. We work together to plan the project, check progress, and make sure every member understood their role. And in this meeting, we assign objectives to the members. We discuss the main responsibilities, clear and honest, right, and select the topic and script. This meeting focused on organize the report. The team leader reviewed the work, assigned responsibilities, checked progress, and made sure all members were consistent. Here we assigned topics each member. We also discussed possible problems and confirmed that all tasks were moving smoothly and as scheduled. This slide introduces our essay section. The essay is about the positive effects of our artificial intelligence on students and education. This page shows the introduction and main ideas of the essay. It explains that AI helps students learn faster, access information, and improve academic performance. This part explains how AI helps students through personalized learning, feedback, accessibility, and reducing learning gaps. It also shows the source used the essay. This section explains how AI saves students time. It helps with summarizing, note organization, planning, writing, and understanding the difficult topics faster. This page explains that AI makes information easier to access. It gives students summarize, explain examples, and learning resource. But students should still use it carefully. This slide shows the impact of AI on the learning efficiency and list the courses used to support the essay, such as reports and academic research. This table shows how the essay was divided. Halima, Faisal, and Ashraf completed different positive points. Fatima wrote the information while Ziad and Nofel, me, collect sources. And here now we move to the social media section. This part shows evidence of posts made by the group member on different platforms. This slide shows TikTok posts made by group members. This post present student life, university experience, and academic activities. This Facebook post shows our academic experience and university life. They also prove that members completed the social media tasks. This slide presents Instagram posts. The post use pictures and caption to describe campus life, studying, and personal learning experiences. Yeah. And if I'm going to this slide shows Twitter posts from the group members. They are short posts about our academic journey and university experience. This section shows our the report tasks were divided among the members. Each member had a clear responsibility. This slide presents Ashraf's individual task and shows his contribution to the report. This slide shows Halima's work and proves the contribution to the group assignment. And this slide presents Fatima Zahra's individual work and her part in the report. And this slide shows Faisal's assignment task and report section the completed. He completed. And this slide present Ziad's individual contribution to the report and group work. And this slide now we move to the resume and cover letter section. This document shows our professional writing skills. And we are going to this slide. This slide presents Halima's resume and cover letter, including her education skills and career goals. This slide, Faisal resume and cover letter. They present his qualification and professional interests. This slide present Ashraf's resume and cover letter. Oh, sorry. This slide is my slide. It shows resume and cover letter showing this academic background, my skills, and everything is provided here. This slide is Ashraf's resume and cover letter showing his academic and background and skills. This slide is shows Ziad's resume and cover letter introducing him professionally from future opportunities. This slide is a final slide presented by Fatima Zahra's resume and cover letter. It shows her skill, experience, and the readiness for future work.
This section presents the questionnaires we completed to understand our learning styles and approaches. The questionnaires helped identify the preferred learning style. The results show scores for activists, reflector and theorists, and pragmatic styles. These styles are individual traits to each of our members. They mean the person prefers either to observe, think carefully, and review information before making decision. The questionnaire evaluates different roles within the team. The results show strong scores in roles such as resource investigator, which is Ziad, and implementer and coordinator and monitor, which is Halima and Faisal. These roles reflect practical thinking, organization, teamwork, and the ability to support group objectives. In team evaluation, we present measures each member's participation and responsibility and communication and basically the attendance. As you can see in this table, it shows marks and observations for each member. Most members received high scores because they were responsible, cooperative, and punctual, and hardworking, and did not miss, and did not even though some of them they did not complete the assignment. This section explains how we managed our time during the semester. We created a clear schedule to follow and to tackle the assignments and complete every task before the deadline. The schedule covers all 18 weeks we had during the semester. We began with group organization, resumes, cover letters, reports, and the essays. After that, we completed presentations, exam presentation, and we had the midterm and the thesis writing, and finally the PPT, which is the PowerPoint, before the submission. This marked the end of this course. Firstly in this semester, and it also concludes our presentation. Thank you for your time and attention.
From this project, I learned how to improve my academic writing and also how can I work in one team and manage my time. And also I'm so proud because I have a wonderful team. Finally, I want to give a big thanks to my Professor Wallace, who gave me a chance to be a team leader of this group. Thank you so much for his efforts.
I would like to sincerely thank our academic English Professor Wallace for all of his support and guidance throughout this course. Thank you, Professor Wallace.
Hi, since I've been working in this project, I'm taking this course. There's lots of good things happen with me. Especially, I got a team who worked very hard work, and I got very renowned team member working is very good thing for me, and I got new skills like how to write thesis, personal statement report, and making presentation video. It's improved from backbone of my foundation is like so renowned for me, and I'm going to thank my team leader, my whole team member who worked hard, and especially teacher Wallace who did renowned things for us, and I'm very appreciate that I got this course.
From this course, I've learned how to manage my time, work with my teammates, and I want to thank my teacher, my team members. It was a wonderful time to spend with them, and thank you.
Due to this course, I have gotten the chance to work with amazing teammates ranging from ones that took care of the sources gathering and one that were creative enough to come up with solutions when almost everything went awry. In this course, we have learned many skills that will benefit us in the upcoming future. Some of the skills are truthfully and honestly crucial when it comes to a bachelor degree, like thesis report, which is a mandatory skill that one must develop to at least acquire their bachelor degree. And in addition to that, we've worked on many projects like meeting minutes and essays that were honestly they were so responsible in the future, and also these reports aid us in understanding the whole idea of what is academic writing. This course is taught by teacher Wallace, an amazing teacher and a great tutor at that, and a mentor also. So my sincere thanks goes to Professor Wallace, and also I have to thank the team leader Halima, which guided us in this journey to finally achieve something that is of worthy. And we can't forget the team members that were honestly a joy to work with. Thank you.
As for my feedback, before this course I struggled with structuring essays and citing sources. Now I know how to write a clear thesis, build strong paragraphs, and use proper citations like APA. This class benefited me by making me a more confident and organized writer. I no longer fear writing assignments, and I feel ready for future research papers. Finally, I want to say a big thank you to Professor Wallace. I truly appreciate your teaching style. You explained everything in a simple and patient way. Your feedback on my group's project was specific and very helpful. It showed us exactly what to fix and how to improve. Overall, this was a great learning experience. Thank you for for making academic writing less intimidating and more enjoyable.
Thank you, Professor Wallace.
If you like our video, please vote for us.
That was an insightful presentation highlighting the importance of innovation in energy management. Thank you to Group 15. To our fellow judges, you may now proceed with your evaluation. And audience members, please cast your vote if you enjoyed their presentation. And as we come to the end of me and Miss Malak's session, we would like to invite a new pair of hosts, which is Miss Halima and Mr. Satrio. The floor is now yours.
Our next presenters are Group 15, who will present on their thesis and smart grid system and their efficiency. As global energy demands continue to grow, smart grid technology is becoming increasingly important. This research explores how intelligence power distribution system can improve efficiency, reliability, and sustainability in modern energy network.
A smarter energy system means a smarter future for us all. Please join me in welcoming Group 15 to the stage.
Hi everyone, my name is Halima Naji. I'm from Morocco. My major is engineering.
You have to call group 16, 17.
I apologize, Group 16. We welcome Group 16 to the stage.
Good morning, everyone. Today we are Group 16 and we are honored to present our academic writing projects. During this semester, we completed several academic tasks, including a thesis, an academic report, an essay, questionnaires, formal reports, resumes, and many supporting documents. In this presentation, we will briefly introduce our work and explain the learning outcomes we achieved. Thank you for your attention. This slide introduces our group members. Our team consists of 7 students, and each member contributed to the project according to their assigned responsibilities. We work together throughout the semester and support each other to complete all tasks successfully. This slide shows the detailed division of work. Every member completed different parts of the thesis, report, essay, and other assignments. By dividing the work clearly, we were able to finish the project efficiency while maintaining good quality. Here we present an overview of all the work submitted during this course. It includes our thesis report, academic report, essay, questionnaire, resumes, cover letter, formal reports, meeting minutes, and learning outcomes. This demonstrates the amount of work completed through the semester. This is the roadmap of today's presentations. We will introduce each section of our project step by step, beginning with our thesis and ending with our reflections and learning outcomes. I will let you guys with a simple introduction of our team.
Good afternoon, Professor Wallace, classmates, and respectful guests. We are Group 16 and we are happy to represent our final exam presentation of Academic English Writing course. My name is Aya, I'm from Morocco and my major is Aeronautical Engineering. And I had the privilege to be the team leader of such a wonderful team, and we shared multiple experiences and memorable moments. And it's an honor for me to represent my team.
Hi, my name is Maisal Idrisi and I'm a 20 years old Moroccan student studying Bachelor in Aeronautical Engineering. I came to China in 2024. This is my second year. I studied my first year as a language student in Harbin, and this year I'm studying Aeronautical Engineering in NUAA.
Hello everyone, my name is Walid Mouchbouch from Morocco. I'm mechanical engineering student.
Hello everyone, I'm Bishop from Nepal and I'm studying aeronautical engineering in Nanjing University of Aeronautics and Astronautics.
Hello everyone, my name is Badr. I'm from Morocco. My major is mechanical engineering. So, in this semester, we worked as a group. We faced our problems by the teamwork and the patience.
Hello everyone, my name is Blessing Mutonkole Mwanza and I'm from Congo DRC.
I'm currently studying mechanical engineering at Nanjing University of Aeronautics and Astronautics.
Hello, my name is Firas. I am a student at Nanjing University of Aeronautics and Astronautics. I have a big interest in engineering and aviation technology, and I like to get a new challenge.
First thing, we're gonna introduce our thesis report evidence. From the slides 6 to 18, they present evidence from our thesis report. They include different pages from the final documents and demonstrate that the research was completed successfully. Our thesis focuses on engineering research and follows a formal academic structure with proper references and supporting informations. Second part, it's from the slides 19 to 27. This slide shows evidence from our academic report, and the report was carefully organized with clear sections, reliable sources, and academic writing standards. This work helped us improve our research and analytical writing skills. From the slides 28 to 30, these slides provide evidence of our social media assignments as part of the course requirements. Each member completed outline communications task and documented the results. From the slides 31 to 34, the section presents our reports and essay evidence. We completed different types of formal reports and also worked together on a group essay. This assignment helped us improve our academic writing and teamwork. From the slides 35 to 42, these slides continue with evidence from our essay. The essay was supported by research, logical organization, and proper academic language. We also include a mind map to explain the structure of the essay. From the slides 43 to 49, here we present our resumes and cover letters. Every group member prepared professional career documents to practice writing in a formal and professional style. From the slides 15 to 54, these slides show the result of our questionnaires. The questionnaires helped us understand our learning style and team roles. They also allowed us to reflect on our strengths and how we contributed to the group. From the slides 55 to 16, these sections included our team evaluation meeting minutes and project schedules. We held regular meetings, assigned tasks, monitored our progress, and managed our time carefully. From the slides 61 to 64, the slides explained individual learning outcomes. Every member improved different academic skills such as research, report writing, academic English, reflection, editing, and presentation skills. The slide 65 summarized our group learning outcomes. By working together, we learned how to divide the responsibilities, communication effectively, solve problems, meet deadlines, and complete a large academic project as a team. Slide 66. Now we begin introduction our thesis, which is titled CFD Analysis of Airflow and Cooling Efficiency in Aircraft Cabins. This research studies how computational fluid dynamics can be used to improve aircraft cabin ventilation and passenger comfort. The slide 67 explains our research statement and research question. Our goal was to investigate airflow distribution, cooling efficiency, and thermal comfort inside aircraft cabins. Here we describe our research methodology. We followed a quantitative approach using CFD simulation. The process included literature review, CAD modeling, mesh generation, simulation result analysis, and optimization. This line explains why this research is important. Aircraft cabins require efficient airflow to provide passengers comfort while reducing energy consumption. CFD offers a cost-effective way to analyze and improve ventilation systems. Slide 17. This slide introduces the background of the study. We explain the engineering challenges related to airflow distribution, cooling efficiency, and the balance between passenger comfort and energy use. The slide 71. Here we present the objective and scope of the research. Our objective was to analyze cabin airflow using CFD, evaluate the current ventilation system, and identify possible improvements while keeping the study within realistic engineering conditions. The slide 72 summarizes the organization of the thesis and the theoretical background used in the research. It shows how the project was planned and completed step by step using engineering principles. In conclusion, these projects allowed us to strengthen our academic, writing, research abilities, teamwork, and presentation skills. We also gained valuable experience in engineering, research, and professional communication.
Hello everyone, hello teacher. I'm Blessing Tankoli from group 16 and I'm gonna present the thesis objective scope. Our objective was to use CFD to model, evaluate, and organize cabin airflow and cooling. We built a 3D cabin session with human mannequin as its source and simulate airflow and temperature under press condition to find stagnant or uncomfortable zone. The scope was a twin HES cabin session, steady state, and compressive, using range turbulence models excluding taxi, takeoff, leading, and structural effects. Our second part, we talk about thesis organization. Our thesis organization has seven chapters, introduction, literature review, theoretical background, methodology, simulation, step, results, and conclusion. Today's presentation focus on chapter 1, 3, 4, and 5, the theory and methodology beyond the simulation. And here we're gonna talk about CFD foundation governing equation. CFD numerically solve the equation governing fluid flow and its transfer. Free conservation law underpin its mass for the continuity equation momentum through the Navier-Stokes equation, which drive the simulation, and energy, which predicts the temperature fluid. We assume steady and compressive flow use the Poissonian approximation. For buoyancy and a no-slip condition at all worlds. For our second, we talk about turbulence modeling. Since cabin airflow is turbulent, we use the RAMS R and J K epsilon model, which outperforms standard K epsilon in enclosed space. It solves for turbulence, kinetic energy, and dissipation rate with 10% turbulence intensity at the inlet Near walls, we need wall foundation. We need wall function, inside of an ultra-fine mesh, keeping Y plus between 30 and 300. Boundary condition. We define 4 boundary type: the Healy at the ceiling diffuser set to 2.6 meter per second and 10 liter per second per person. The Healy pressure Healy at 1 atmosphere near the floor a week longitudinal flow along the cabin that spread contaminate row to row, and the wall 3D has smooth and no slip across wall, seat, and passenger. For our last, and we will talk about mesh generation, particle transport. We use a polyhedral mesh since it needs pure cell converge fast and endless curved surface better than a tetrahedral mesh. A Green's independence test compare coarse, medium, and fine mesh. And the medium mesh at 7.5 million cell matched the fine mesh and was selected for contaminant. We use the discrete phase model to track droplets as individual particles on way coupled with the airflow, with turbulent dispersion added through the discrete random walk model.
Hello everyone, my name is Walid Mujkush, and I'm here in behalf of my group AR16 from Nuaa. Today, I'll be presenting the results and conclusion from our CVD analysis of an aircraft cabin ventilation system. This study, conducted under the guidance of our Prof. Wallace, aims to quantify the performance of a current cabin design and lay the groundwork for future improvement. We'll cover the performance baseline established for airflow, temperature, and cooling efficiency. Then move on to our key findings and the recommendation we have for future engineering works. To begin, we established a performance baseline for the current cabin design using steady-state SCVD simulation with a medium Mach of 2.8 million seats. The pressure and turbulence analysis show a stable airflow distribution. We have a pressure differential of 150 pascals to drive the flow, and turbulence intensity and the passenger zone is low and comfortable at 6.2%. Based on our findings, we have several practical recommendations for engineering teams. And now, guys, we'll let you a video about our group AR16.
I would like to express my sincere gratitude to our Professor Wallace for guiding us throughout this course. We learned many valuable skills such as writing well-structured reports, preparing professional cover letters, and improving our formal writing style. These lessons have strengthened our communication skills and will be very useful in our academic and future professional lives. Thank you for your patience, support, and encouragement. We truly appreciate everything you have taught us.
Special thing about this course is that we've been working into groups. We were divided into groups. So I was so happy working with my team. we were like helping one to another by giving feedbacks and supporting each other in our homeworks and like improving our writing. So I'm so happy about like this experience.
Okay, so thank you so much for the group. Now we go to the next. Thank you so much. Please invite the next presenter. Your microphone is closed, Mr. Satria. Halima, please invite the next
Thank you, Group
presenter.
16, for showing us how simulation technology contributes to safer and more reliable air travel. Judges, you may now begin your evaluation, and audience members, please remember to support your team with your vote.
Finally, we invite Group 17 to present their research titled Optimizing Transition, Aerodynamics, and Control Law Design for Tittle Rotor eVTOL aircraft under wind gas disturbance. As electric vertical takeoff and landing aircraft continue to gain attention, ensuring stable and safe transition between however, and forward fly remain a significant engineering challenge. This research investigates how aerodynamic optimization and advanced control systems can improve aircraft performance under challenging wind conditions.
The future of urban air mobility depends on solving these challenges like these. Please give a warm round of applause to Group 17.
Afternoon, respected Professor Logie Wallace, respected teacher, invited professors, and my dear classmates. I am Farizanat Oishi, team leader of Group 17, currently studying aeronautical engineering at Nanjing University of Aeronautics and Astronautics. Before we dive into the technical details of our research, I would like to take a brief moment on behalf of Group 17 to express our profound gratitude to our academic English writing professor, Professor Logie Wallace. The rigorous communication training, advanced structural guidelines, and high standards of clarity you instilled in us during our course were fundamental in shaping our written thesis and organizing this very presentation. We didn't just teach us how to write. You taught us how to articulate highly complex technical frameworks with precision and academic integrity. For your unwavering guidance and mentorship, we thank you. With that foundation, this is our privilege to present our thesis titled Optimizing Transition Aerodynamics and Control Law Design for Tilt-Rotor eVTOL Aircraft under Wind Gust Disturbance. This topic is deeply related to aircraft aerodynamics, flight dynamics, and robust control system design. In simple words, our research focuses on how a tilt-rotor eVTOL aircraft can fly safely during the transition from hover to cruise, especially when the vehicle encounters severe wind gust disturbance. During this presentation, we will explain our work step by step, covering the background, aerodynamic modeling, control law strategy, simulation setup, result, and our This slide gives us the overall framework of our thesis. This main problem is that A tilt rotor eVTOL aircraft changes its flight mode entirely during the transition phase. In hover, the rotor point upward to provide vertical lift. In cruise, the rotor tilts forward to provide thrust, and the wing carries the vehicle's weight. However, during the middle transition phase, the aircraft operates in a highly volatile mixed condition. This is difficult because multiple factors shift simultaneously: the direction of thrust, the source of lift, aerodynamic interaction, paces, mass inertia distribution, and control authority. To handle this problem, our thesis utilizes four main technical pillars: a nonlinear 6 degree of freedom light dynamics model, rotor wing dynamics, interaction modeling, advanced control allocation, and ADRC with LESO for real-time disturbance rejection. The final goal is to drastically improve flight stability and trajectory tracking under wind gust disturbance. Now, the third slide presents presentation outline. Our presentation is divided into a clear research flow. First, we will provide the introduction and background. Second, we will explain our aerodynamic modeling and system framework. Third, we will discuss the robust control law design strategy. Fourth, we will talk through the simulation and validation setup. Finally, we will analyze the performance results and summarize our conclusion, limitations, future work, and learning outcomes. This structure directly mirrors our thesis paper, ensuring a clear logical flow from problem identification to final validation. The fourth slide shows our group members. This slide introduces the team behind this project. Our group has 7 members: myself, Farizanat Oishi, the team leader; Manik Rimal, my deputy team leader; Isha Jahan Oishi, Maryam At Nasser, Umaima El-Baghdadi, Heza Sattar, and Patrick Gustavko. Each member fully participated in the preparation of both the thesis and this presentation. We worked closely together as one team, but each member assumed primary ownership over a specific technical block. As a team leader, my role was to coordinate the workflow, guide the structural integration, and compile the final conclusion aspects and assumptions.
Hi, my name is Patrice Gustav Kwab. I am a Ghanaian student studying at Nanjing University of Aeronautics and Astronautics.
Hello everyone, I'm Hajjat Sattar from Morocco, studying aeronautical engineering. My team and I are truly excited to present our thesis to you today.
Hello everyone, I'm Farizanat Oishi, and I'm from Bangladesh. I'm the team leader of Group 17, and I'm currently studying at Nanjing University of Aeronautics and Astronautics, majoring in aeronautical engineering.
Hello, my name is Manik Rimal and I'm from Nepal. I'm currently in my first year of aeronautical engineering at Nanjing University of Aeronautics and Astronautics, NUA.
Hello everyone, my name is Umaima and I'm from Morocco. My major is aeronautic engineering. I'm a student at NUAA in the academic writing courses. I'm part of this thesis group, and my role is to work on simulation, environments, and setup, contributing to the development of our reports.
Hello everyone, my name is Isra Chan Oishi. I'm from Bangladesh and I'm a team member of Team 17. Right now, I'm studying aeronautical engineering and I'm a first year student right now in Nanjing University of Aeronautics and Astronautics.
Hello everyone, my name is Maryam At Nasser. I'm an aeronautical engineering student from Morocco. My teammates and I are here to present our work.
As we move to the 5th slide, work division and contribution. Looking closer at our detailed contribution matrix, Isha Jahan Oishi focused on the introduction, literature background, abstract, and the final editing. Manik Rimal engineered the aerodynamic modeling and system framework. Patrick Gustav Coe and Heza Sattar designed the robust controls law strategy. Umayma Il-Baghdadi and Maryam Atnasser carried out the simulation runs, parametric studies, and the matrix validation. And I handled the conclusion, future roadmap, and modeling assumptions. Although in individual sections were assigned, the final system was completed through rigorous group review and collaborative teamwork, with each member contributing an equal share of 14.28%. Now, moving to the abstract and the keyword map. This slide provides a compact summary of our abstract and keyword map. While tiltrotor eVTOL aircraft combines the best features of vertical takeoff and fixed wing cruise, their transition corridor remains highly sensitive to instability. Our paper proposes a robust model-based control framework utilizing a 6 degree of freedom dynamics, rotor wing coupling, continuous control blending, ADRC, and LESO state observer in a MATLAB or Simulink environment. The core keyword mapping our research includes tiltrotor, eVTOL, transition, aerodynamics, ADRC, LESO, wind gas disturbance, and trajectory tracking. Now that I have established our team framework and thesis overview, I would like to invite Ishrat Jahan Oishi to continue with Chapter 1, Introduction and Background. Thank you, everyone. Thank you, Faria. Good afternoon, everyone. I'm Ishrat Jahan Oishi, and I will present Chapter 1, which includes the background, importance, research gap, research question, and methodology of our thesis. Before going into questions and simulation, it is important to understand why this topic matters. This chapter answers 3 questions. Why are eVTOL aircraft important? Why is tiltrotor transition flight difficult? And why do we need a robust control system under wind gust disturbances? Urban transportation is facing many challenges, such as traffic congestion, pollution, and limited ground space. Because of this, advanced air mobility has become an important research direction. eVTOL aircraft can take off and land vertically, so they do not require long runway. This makes them suitable for future urban air transport. Among different eVTOL configurations, tiltrotor aircraft are very promising. Multicopters are good in hover but have limited cruise range. Lift plus cruise aircraft separate lift and forward propulsion, but some motors are unused during cruise. Tiltrotor aircraft provide a better balance. They can take off vertically like helicopters and cruise efficiently like fixed-wing aircraft. But this advantage creates one major challenge, the transition phase. This slide shows the main technical problem of our thesis. In hover mode, the rotors point upward and provide most of the lift. In cruise mode, the rotors point forward and the wing produce most of the lift. But in transition, the aircraft is between these 2 modes. During this time, rotor lift decreases, wing lift increases, thrust direction changes, drag changes, and control authority shifts from rotor to aerodynamic surfaces. This can cause instability if the control system is not designed carefully. The risks include altitude drop, pitch oscillation, path deviation, and actuator saturation. So, transition flight is not just a normal flight phase. It is the most sensitive part of tiltrotor eVTOL operation. Now, let's talk about low altitude wind gust disturbance. The problem becomes more serious in low altitude urban airspace. Near buildings, wind is not smooth. It can become turbulent because of building age, rooftop flows, thermal drafts, and wind shear. If a sudden gust hits the aircraft during transition, the aircraft may lose altitude or deviate from its path. This is why our thesis focuses on wind gust disturbance rejection. A normal controller may work in calm conditions, But a safer transition controller must handle unexpected disturbances. Previous research has used several control methods for aircraft, such as PID, LQR, gain scheduling, sliding mode control, MPC, and age infinity control. These methods are useful, but each has limitation. PID is simple, but it may not handle nonlinear transition well. Gain scheduling works at selected flight points, but transition changes continuously. MPC can handle constraints, but it may require more computation. Age infinity is robust, but it can become conservative. The research gap is that tilt-rotor transition flight needs a controller that can handle changing aerodynamics and estimate unknown disturbances in real time. This is why our thesis uses control allocation together with ADRC and LISO. Now, let's talk about our research question, aim, and objectives. The main research question of our thesis is, how can ADRC and control allocation strategies improve transition flight stability and trajectory tracking performance of tilt-rotor eVTOL aircraft under wind gust disturbances? Our main aim is to develop a model-based robust control framework for transition flight. The objectives are to build a nonlinear six-DOF aircraft model, to include nacelle tilt and time-varying interior effects, to model rotor split stream and wing interaction, to design control allocation across hover, transition, and cruise, to apply ADRC with LISO for disturbance estimation, and to validate the model in MATLAB or Simulink under different wind scenarios. This is how our aircraft will look like if we work on our thesis. If we can collaborate with our university, this is how our aircraft will look like. So, let's move to the next part, our research methodology. This slide shows the research workflow. First, we reviewed previous studies on tilt-rotor aircraft, transition aerodynamics, and control methods. Second, we developed the 6-DOF flight dynamics model. Third, we modeled our rotor slip system and rotor wing aerodynamics coupling. Fourth, we designed the control allocation and ADRC-based control law. Fifth, we tested the complete system in MATLAB or Simulink under 4 wind cases, like no wind, steady wind, gust wind, and turbulence wind. Finally, we evaluated the system using trajectory tracking error, control error, allocator situation, and the robustness. This completes the introduction part. Now, I would like to invite Manik Rimal to explain Chapter 2, Aerodynamics Model and System Framework. Thank you, everyone.
Thank you, Israt. And good afternoon. I'm Manik Rimal and I will present Aerodynamic Modeling and System Framework. This chapter is a technical foundation of our thesis before designing any controller. We must first understand how the aircraft moves and how we can act on it. And our modeling section include coordinate system, 6 degree of freedom motion, Newton-Euler equations, time-varying inertia, rotor slip streams, rotor was, and lift track variation. And then coordinate system of 6 degree of freedom motion. A tilt rotor AVOLT aircraft moves in the 3-dimensional space, therefore we use a 6 degree of freedom model. The 3 transitional motor are surge, sway, and heave. Surge means forward and backward motion, and sway means the slight motion, and the heave means the vertical motion. The 3-dimensional motion are roll, pitch, and yaw. This degree of motion are most important because wind gust can affect not only the altitude but also pitch, roll, yaw, and the path direction. This coordination system helps us to describe the motion correctly, and inertia frame describes the position. The body frame describes the force and motion, and the wind frame describes the aerodynamic coefficient. and governing equation of motion. This slide shows the main equation of motion. The transitional equation explains how the total force creates acceleration. The total force include aerodynamic force, proportional force, and the gravity. The rotational equation explains how moment create roll, pitch, and yaw acceleration. These equations are important because our thesis is based on the real flight dynamics. They form the backbone of the simulation motion. We are not deriving every equation in detail here, but we are showing that the aircraft model has the mathematical foundation. Time variation, inertia during the nacelle tilt. In many simple aircraft models, inertia is assumed constant. But in the tilt motor aircraft, the assumption is not fully accurate because the nacelle rotates during the transitions. When the nacelle moves from the vertical to horizontal, the mass distribution changes the inertia tension. The extra inertia terms in the equation represent the effect of changing configurations during the nacelle rotations. This makes the model more realistic, especially during the fast transition or maneuvering. Rotor slipstream modeling. Rotor slipstream means the acceleration airflow produced by the rotors. In our thesis, the rotor system is modeled using the actor disc theory. The rotor is treated like a disc that adds momentum to the airflow. The equation shows the relationship between thrust, air density, disc area, induced velocity, and slipstream velocity. This method is suitable for preliminary simulation because it is simple and computationally light, because it is still captures the main effect of the rotor generational airflow. The rotor slipstream is important because it can pass over the wing and change the local airflow. And rotor wash effect on wing lift. This slide explains how the rotor wash affect the wings. The wing does not only experience a normal free streams air, it also experiences the rotor-induced airflow. So the effective velocity over the wings becomes the free streams velocity plus the induced velocity from the rotor. Since the lift depends on the dynamic pressure and dynamic pressure depends on the velocity square, and the change in the local velocity is strongly affect lift. The rotor wash can increase the lift during the hover and yearly transitions, but it also can cause the uneven wing loading during drag increase, flow separation, and vibration. Lift distribution during the transitions. This slide shows the transfer of the lift during the transitions. At low airspeed, most of the lift comes from the rotors. Airspeed increase, the wing gradually produce more lift. At higher airspeed, the wing becomes the main lift source, and the rotor mainly provides the forward thrust. This is important for the control design because the controller must also transfer authority smoothly from the rotor-based control to the aerodynamic surface control. So this slide connects the aerodynamic modeling with the control allocation selection. Lift, drag, and polar variation. During transition, lift can drag coefficient and not fix. Rotor-induced airflow change the effective lift coefficient drag the change because drag is related to the lift and airflow conditions. In the middle of the transition, drag can increase, the power requirement may become higher. This means the aircraft aerodynamic behavior can change throughout the conversion corridor. Therefore, the controller must be robust enough to handle changing aerodynamic conditions. Aero-propulsive interaction summary. This slide summarizes the aerodynamic change. Rotor thrust produce induced velocity creates the slipstreams, and slipstreams change the local wing velocity, local velocity change the dynamic pressure, and dynamic pressure change the lift and drag. Finally, lift and drag affect pitch, attitude, and trajectory. This is called aero-propulsive interaction. The main message is that propulsion is the aerodynamic cannot be treated separately during the tilt rotor transition. Now I would like to invite the tactic Gustav Kuao to present the first part of the chapter 3, reverse control, law, design, strategy. And thank you.
Now I will explain the first part of chapter 3, which is control allocation framework. In this chapter, we explain how the aircraft decides which control parts should work differently during different stages of flight. Since the aircraft changes from hovering to forward flight, the control system needs to change very smoothly as well. If you look at slide 24 of control allocation framework, this slide explains the main idea of control allocation. The aircraft has different control parts such as the rotors and then the control surfaces. Instead of using only one part, the system decides how much each part should work. This helps the aircraft stay stable and balanced while using the available controls in its very best way. Now in slide 25, we will talk about the actuator mixing across different flight modes. During hover, the aircraft mainly depends on the rotors for control. During cruise flights, the control surfaces become more important. In the transition, both systems work together instead of changing suddenly from one system to another. The control is shared smoothly. This reduces sudden movement and help keeps the aircraft very stable. In slide 26, we will be talking about continuous bending functions. This graph shows how the control changes gradually during the transition. In the beginning, the rotors do most of the work. As the aircraft gains speed, the control surfaces slowly takes over. The smooth curve shows that the change is continuous instead of suddenly changing. This makes the flights safer and gives the aircraft a smoother response even when there is wind. Thank you very much. I will now hand over the presentation to Satha, who will explain the second part of chapter 3, which is disturbance rejection control. Thank you very much.
Thank you, Patrice. Good afternoon, I'm Hajjat Sattar and I will continue the control law section. So, let's talk is the observer's part of ADRC. It estimates 3 states. The first stage is the output, such as pitch angle or altitude. The second stage is the output rate, and the third stage is the total disturbance. The third stage is the most important because it includes wind gust effects, modeling errors, and rotor wing interaction. When a gust affects the aircraft, the measured output changes. Let's detect these changes and update the disturbance estimate. This next slide shows how ADRC uses disturbance estimate. First, the desired trajectory is given. Second, the aircraft output is measured. Third, the tracking error is calculated. Fourth, LESSO estimates the total disturbance. And fifth, ADRC compensates the control command. Sixth, the control allocator sends feasible commands to the rotor and control surface. And finally, the aircraft returns toward the desired path. So the whole control process is measure, estimate, compensate, allocate, and recover. The next slide answers an important question. Why do we need ADRC? So, We know that PID is simple, but it might need returning when aircraft dynamics change. Gain scheduling can work at selected flight points, but transition flight changes continuously. MPC can handle constraint, but it might require heavier computation. So ADRC is useful because it can estimate unknown disturbances in real time. For our disease, ADRC is suitable because the aircraft faces wind gusts, nonlinear aerodynamics, and the model uncertain during transition. Now we're gonna move from control design to simulation and validation. So after building the model and controller, we need to test whether the system works under different wind conditions. The purpose of the simulation is to evaluate trajectory tracking, control effort, saturation behavior, and flight envelope robustness. This is where our theoretical model becomes measurable simulation evidence. This slide again shows the simulation workflow. First, the aircraft model is defined. Second, the transition corridor is configured. Third, rotor-wing aerodynamics interaction is included. Fourth, ADRC and LESO are added to the control loop. Fifth, wind scenarios are applied. Sixth, the simulation is run in MATLAB and Simulink. And finally, the results are evaluated. This workflow makes the simulation organized and repeatable. 4 wind scenarios are considered. The first is no wind, which is baseline case. The second is steady wind, which gives a constant disturbance. The third is gust wind, which gives a sudden temporary disturbance. The fourth is turbulence wind, which gives random and continuous disturbance. By testing all 4 cases, we can evaluate the controller under both ideal and difficult conditions. This makes the validation stronger than only testing the aircraft in calm air. The gust input is based on MIL F8788C 1 cosine gust model. This is the name of a model used. This gust starts smoothly, rises to a peak, and then returns smoothly. It is useful because it gives a standard and repeatable disturbance input. This allows us to compare the aircraft's response fairly. The main purpose is to check how quickly and smoothly the aircraft can recover after a gust enters during transition. Now I would like to invite Omeima to represent the performance evaluated and simulation results. Thank you, everyone.
Thank you, Hajjaj. Good afternoon. I'm Umayma and I will present the result and the performance evaluation. The control is evaluated using several metrics. The first metric is trajectory tracking error. This shows how far the aircraft moves away from the desired path. The second is altitude deviation, which is very important because altitude loss during transition can be dangerous. The third is control effort, which shows how much actuator command is needed. The fourth is actuator saturation, which checks whether the actuator commands are realistic. A good controller shouldn't only track the path, it should also avoid excessive actuator movement. This slide compared the trajectory in the different wind scenarios. In the no wind case, the aircraft followed the desired path more smoothly. In a steady wind, the paths shift because wind affects the ground track. In gust wind, the aircraft experience local deviation because the disturbance enters suddenly. In the turbulence winds, the trajectory becomes more irregular because the disturbance is random and continuous. This comparison shows that winds has a strong effect on the trajectory tracking. This slide focuses on gust wind response. When the gusts start, the trajectory error increases. Then LESO estimated the turbulence. After that, ADRC compensated the control command. Finally, the aircraft moves back toward the desired trajectory. The important point is not only that the aircraft deviates, but also how quickly and smoothly it recovers. This is why turbulence estimation is important for safe transition flight. Turbulence is more difficult than a single gust. A gust is temporary, but turbulence continues. Over time, it can disturb the aircraft again and again. It can affect altitude, pitch, roll, yaw, and path direction. Because of this, the control must continuously estimate and compensate the turbulence. These tests show whether the control framework is robust under more realistic and difficult wind conditions. This slide summarizes the result discussion. No wind is the easy case. Steady wind creates moderate tracking difficulty. Gust wind creates sudden deviation. Turbulence creates the high tracking challenge. The main result is that the turbulence estimation and smooth actuator blending help improve transmission stability and reduce unsafe behavior. This supports the main idea of RTC. Transition flight needs both aerodynamic modeling and robust control. Now we move to the final chapter, conclusion, prospects, and assumption. This section explains what we found, what limitations we had, and how this work can be improved in the future. A good thesis shouldn't only show results, it should also clearly explain the scope and the boundary of the research. The main findings of our thesis are shown here. First, transition flight is the most sensitive phase because left source, inertia, aerodynamic forces, and the actuator authority all change together. Second, rotor slipstream affects wings velocity and lift, so rotor wind interaction must be included. Third, smooth control allocation helps avoid abrupt switching between the rotor and aerodynamic surface. First, this helps ATRC estimate and compensate wind gust disturbance. Finally, MATLAB Simulink validation under 4 wind scenarios supports the usefulness of the proposed framework. Now I would like to invite my friend Mariam to present the assumption, limitations, future work, and learning outcomes.
Thank you, Umayma. Good afternoon. I'm Mariam Nasser, and I will present the final discussion part before our team leader closes the defense. This slide, 42, explains the assumptions and limitations of our work. The aircraft is modeled as a rigid body, rotor, slipstream is modeled using actuator disk theory. The platform is conceptual, and the validations is simulation-based. The limitations are that we did not include full SFD analysis, blade elements for vortex modeling, and aeroelastic structural flexibility, hardware and the loop testing, or physical flight testing. These limitations do not mean the work is weak. They simply define the scope of our thesis. Slide 43, Future Work Roadmap. Future work can improve this thesis in 3 directions. First, the aerodynamic model can be improved using SFD, blade elements momentum theory, and vortex wake modeling. Second, the control strategy can be improved by comparing ADRC with MPC, sliding mode control, H and infinity control, or adaptive control. Third, validation can be improved using hardware in the loop simulation, wind tunnel testing, and scaled prototype flight experiments. The roadmap shows how the thesis can be extended into more advanced research projects. This slide shows that our presentation is directly connected to our thesis paper. We included evidence from the title page, contribution page, abstracts, methodology, results, and conclusion sections. This is important because our presentation is not separate from the written thesis. It is a visual defense version of our academic work. The figures, tables, equations, and screenshots are used to support our explanation and make a defense more understandable. Slide 45, Learning Outcomes. This slide reflects what we learned from the whole project. Technically we learned about 6 FDOF, flight dynamics, rotors, live streams, transition aerodynamics, control allocation, ADRC, LESO, and MATLAB Simulink simulations. Academically, we learned how to write abstracts, organize methodology, prepare figures and tables, cite references, and structural thesis. As a group, we learned teamwork, communication, responsibility, time management, and how to combine different sections into a complete project. This project helped us improve both of our technical understanding and academic writing skills. Now we're moving to slide 46. It's about references. This slide shows the academic foundation of our thesis. Our references include books and papers on aircraft dynamics, rotorcraft, aerodynamics, robust control, ADRC, AVTOL design, and wind gust modeling. We will not read every reference one by one, but this slide shows that our thesis is supported by relevant academic sources.
This will be the final design of Prosperity 1. As with the proof of concept, you can see there are 8 lifting propellers to lift the vehicle and propel it above the critical speed to become airborne using the wings. Once the aircraft is carried by the wings, the lifting propellers are set to locked, so the aircraft conserves energy and flies quietly. To maintain airspeed and wing-borne lift, a pusher propeller drives the aircraft forward. The converting between these two elements is a critical flight phase called the transition. The transition between being lifted by vertical propellers and being carried by the wings of an aircraft. This requires complex aerodynamics to be taken into account. When designed and engineered correctly, the maneuver will be smooth and safe. If not designed or performed properly, the procedure will be bumpy and unstable, and the aircraft may lose altitude during transition.
The rule makers make the rules, and for eVTOLs, they're still being developed, and we're really lucky that we're a little bit later in the game, because the leading players have to work with the changing rules. So the rules settle down, but they tell you things like the climb rate you require, the obstacle clearance you require, they define what the vertiports are going to be like, and all that sort of stuff. So you now know what the challenge is. You know what I need to do to operate it there safely, so you know what it is. So that's being worked on now, and by the time we get there, we'll be in great shape.
Now I would like to invite our team leader, Faria Zanas Oishi, to close their presentation with the final defense summary.
Thank you, Miriam. As a team leader, I will now bring our final defense presentation to a close. The final defense summary. The central conclusion of our thesis remains firm. Tilt-rotor eVTOL transition flight is exceptionally complex because the rotor angle, lift source, inertia distribution, dynamic interaction, and actuator authority all shift continuously and simultaneously. Low-altitude urban wind gust amplifies this vulnerability significantly. To resolve these challenges, our thesis successfully combined 4 core technical elements: a non-linear 6 degree of freedom, flight dynamic modeling, a detailed rotor wing dynamic interaction model, a smooth sigmoid-based continuous control allocation framework, and a ADRC controller equipped with a linear extended state observer for a real-time disturbance tracking. Our comprehensive MATLAB simulation under no wind, steady wind, discrete gust, and continuous turbulence strongly support the validity and performance of this proposed framework. Therefore, our definitive final thesis statement stands. Safe tilt-rotor eVTOL transition requires accurate aerodynamic modeling, smooth actuator blending, and robust active disturbance reject control.
So beyond the technical knowledge, in this class I was able to learn the value of teamwork, clear communication, and team management skills that will help me throughout my life.
During this semester of academic writing, I have learned how to write and then also improve my resumes, my cover letters, my report writings, and thesis.
Thank you, Group 17, for sharing your research and innovation with us. Judges may now complete your evaluation, and audience members, if you enjoyed today's presentation, please remember to cast your vote.
It was an excellent way to conclude our session of presentation. Let's give one more round of applause to Group 17 for sharing their outstanding research with us.
God damn it. Excuse me. After that is 14. Please stand by.
Hello everyone, and
Please
now
give a
welcome
warm
to
welcome
our
to Group
presentation.
14.
We are Group 14, students from Nanjing University of Aeronautics and Astronautics, enrolled in the academic writing course. Today we'll be presenting our thesis project on impact of next generation of smart suspension system for automobiles. Our group members are Ryan, Isan, Sultana, Amne, Steven, and myself, Frank, the group leader. In addition, Steven is a deputy leader, assisting with coordination and organization of the project. In our presentation, we will explain our research in a structured way, covering the main ideas, analysis, methodology, and conclusion developed throughout our thesis work. Each member will present their assignment section, ensure a clear and well-organized discussion. We have a short video to introduce our team. Hello everyone, my name is Frank. I'm from Brazil. I'm doing mechanical engineering, and I'm a student from the University of Aeronautics and Astronautics in the academic writing course. I'm the group team leader of this project, and I'm responsible for coordinating the group and contributing to conclusion and discussion.
Hello everyone, my name is Steven and I'm from Republic of Congo. I am an aeronautical engineering student at Nanjing University of Aeronautics and Astronautics, member of the Group 14 with the project that we have been working so hard, next generation of smart suspension system for automobiles. Thank you so much, guys.
Hello everyone, my name is Ryan Marzak, I'm from Morocco. I major in aeronautical engineering from Nuaa. I'm enrolled on the academic writing course. In this group thesis, I'm responsible for literature review on conventional and smart suspension systems, where I will focus on supporting the research and analysis.
Everyone, my name is Sultana Bilwat. I'm from Morocco. I'm a student at Nanjing University of Aeronautics and Astronautics, currently studying in academic writing course. I'm glad to be part of this project, where I will be contributing to the introduction part.
Hello everyone, my name is Mohammed Amin Slaki. I'm from Morocco. My major is electrical engineering and I study at Nanjing University of Aeronautics and Astronautics in the academic writing course. For this thesis project, I'm responsible for methodology section and I will be presenting part of our findings.
Hello everyone, my name is Ihsan Bilfalah. I'm from Morocco, a mechanical engineering student at NUAA in the academic writing course. I am part of this thesis group and my role is to work on the literature review, sensors and AI, contributing to the development of our report.
In the abstract, the development of automotive technology has improved the vehicle safety, comfort, and handling. The key innovation is the next generation smart suspension system, which adapts to road conditions using sensor and control systems. This study compares the smart suspension system with conventional ones, focused on ride comfort, stability, and road holding performance. The research is based on literature review and computer simulations. The results show that smart suspension vehicles reduce vibration, improve handling, and increase tire road contact. However, they are more expensive and they require more complex maintenance. Overall, a smart suspension system significantly improves the vehicle performance and safety, making them a promise developed for future automotive design.
Let's start with an easy example. Imagine driving on a humpy road. You feel every hole. After a long drive, you are very tired. Now imagine the same road, but you feel almost nothing. You arrive fresh. What makes this difference? The suspense system. Suspense has three jobs. First, it makes the ride smooth. Second, it keeps the car stable in turns and stops. Without it, you could roll over. Third, it works on all roads, highways and dirt roads. Here is the big problem. For comfort, you need a soft suspense like a luxury car. For health, you need a stiff suspense like a sport car. Traditional suspensions make you choose one. You cannot have both. This is the comfort hidden trade-off. Traditional suspensions have fixed parts. They cannot change. Imagine a suspension made for a smooth highway. Then you drive on a rough road. You bounce around. The suspense cannot adapt. This is why we need smart suspensions. Smart suspensions use sensors. They collect information. Computers control the system in real time. They solve the comfort handling problem. There is two types. Semi-active. Adjust and damping use little power. Fully active creates its own force, best performance, more energy. In our research, we compared smart suspensions with traditional one. We use MATLAB and simulations. We tested comfort, stability, and handling. We use ASO standards for our tests. Our results were very good. Smart suspensions reduce shaking by over 60%. They keep tires on the road during emergencies. They work best on road. To summarize, smart suspensions are the future. They achieve both comfort and control at the same time. Traditional suspensions cannot do this. Soon, smart suspension will be in all cars, not just luxury cars. Now I will hand over to Ryan. Thank you for your listening.
Thank you, Sultana. Good morning, everyone. My name is Ryan Marzak, and I will be presenting the literature review on conventional and smart suspension systems. Semi-active suspensions bridge the gap between passive simplicity and active performance with minimal energy cost. They give you near active performance with only passive level energy consumption. This is why they become so important. Passive suspensions use fixed spring and dampers with predetermined settings. They are inexpensive and reliable, but according to Florence research, their performance depends entirely on initial spring and damper selection. If conditions change, you're stuck with poor performance. They simply cannot adapt. The key innovation in semi-active suspension is skyhook damping, introduced by Carnop in 1974. Imagine an imaginary damper between the vehicle body and the fixed point in the sky. This allows continuous adjustment of damping forces in real time. It modifies energy dissipation without generating new forces, so it doesn't require much power. Severity showed the semi-active system delivers significantly better ride quality and road holding than passive systems. Here is the timeline. Early 90s, Leaf Spring, 1974, Carnop semi-active concept, 1980s to 1990s, active control research growth, 2000s Skyhawk H-Infinity LPV methods. 2020s machine learning, AI, predictive control. This progression is accelerating. Active suspensions generate external forces through actuators, sensors, monitor body, acceleration, and suspension movement. The controller calculates responses, actuators generate corrective forces. Both developed electromagnetic suspension with exceptional ride comfort, but energy requirements and costs limit widespread adoption. Here is a comparison. Passive, no adaptability, no power, low cost, acceptable comfort, mass market, semi-active, damping adaptability, minimal power, medium cost, good comfort, premium vehicles. Active, full control, high power, high cost, excellent comfort, luxury vehicles. It has its place, but the trend is clearly toward intelligent systems. The literal conclusion is clear. Passive dominates budget segment, but is inherently limited. Semi-active provides the best compromise between affordability and performance. Active remains the benchmark for maximum performance. Goodall, Corton, and Bose all agree real-world applications are already here. Cadillac uses magnetic ride control with magnetorological fluid. Mercedes-Benz has active body control and Audi has adaptive air suspension. BMW uses adaptive drive. Smart suspension is transitioning from luxury to mainstream. Future directions are exciting. Boss's electromagnetic suspension shows promise. Spinner and Morel are developing AI predictive control where systems predicts road conditions and adjust parameters in advance, enabling truly autonomous adaptive suspension. The key trend smart suspension is moving from luxury feature to mainstream standard. Our research supports this transition. Thank you. I'll hand over to Ihsan for sensors and AI.
Thank you, Ryan. I'll be presenting the literature review on sensors, control systems, and artificial intelligence. Sensors are the eyes and ears of the suspension system. Without them, the system would be blind. Multi-sensor fusion combines inertial position and vision sensors to enable predictive control. The system can anticipate what's coming rather than just reacting. Inertial sensors, particularly MEMS technology, are the heart 6 of IMUS with 3-axis accelerometers and 3-axis gyroscopes come in an compact package, just 4.5 by 4.5 by 1.1 millimeters. They're ISIL B compliant for functional safety. They're used for vehicle attitude, acceleration, angular velocity, rollover detection, and active suspension. They're compatible with deep learning models. Position sensors measure suspension, displacement, and ride height, monitoring relative motion between sprung and non-sprung masses. Road detection uses machine vision and LiDAR 2D image processing detects puddles. 3D point code analysis provides detailed road surface mapping. Combined this gave a comprehensive picture. This shows sensor integration in the vehicle architecture. Inertial MEMS devices through the vehicle. ESC units process data from gyroscopes and accelerometers, rollover sensors, motion detection, and navigation all feed into suspension control. This integration enables real-time intelligent response. Multi-sensor fusion combines accelerometers, gyroscopes, camera, and LiDAR to compensate for individual limitations. ML enhanced 2D plus 3D fusion improves accuracy. Benefits include proactive adjustment, mitigating time delays, and building the foundation for autonomous vehicle integration. Now let's discuss control algorithms. From PID to reinforcement learning, AI-driven algorithms are transforming suspension performance. PID control is the foundation. It generates forces based on error between desired and actual states. The proportional integral and derivative terms address different response aspects. PID is effective for low frequency chassis control below 1 Hz. Studies show a 5.37% reduction in vertical acceleration on flat roads. Fuzzy logic control handles uncertainties and nonlinearities effectively. It uses role-based decision-making, mimicking human reasoning. Advanced integration includes variable universe fuzzy PID with road recognition. This provides superior comfort handling trade-off management. Here's the PID controller block diagram showing how the system processes reference signals. Measures actual states and generates control signals. Machine learning approach push further. Deep learning uses CNNs for road condition recognition. TD3 reinforcement learning enables autonomous PID turning, cooperative control with steering and braking, high hierarchical control, and ADAS compatibility. To summarize, the combination of advanced sensors, sophisticated control algorithms, and AI integration creates a suspension system that perceives, decides, and acts in milliseconds. This makes the next generation truly revolutionary. Thank you. I'll hand it over to Amin for the methodology.
Thank you, Ihsan. And now I will be presenting our methodology. We use a quantitative comparative design to evaluate passive and smart suspensions under identical controlled conditions. This allows direct comparison. Our research follows 7 steps. Develop models, simulate passive, simulate smart, apply inputs, collect data, compare results, evaluate performance. This systematic approach ensures reliable results. Independent variables, suspension type, passive or smart, road conditions, smooth, rough, speed bump, uneven, and vehicle speed, low, medium, high. Dependent variables, vertical body acceleration, suspension displacement, tire deflection, body roll, and pitch angle. Controlled variables, vehicle mass, tire characteristics, suspension geometry, road profile, and simulation duration of 5.0 seconds. Performance criteria. Ride comfort uses RMS vertical acceleration per ISO 26311 vehicle. Stability uses body roll, pitch, and suspension travel. Road handling uses tire deflection and dynamic tire load. Improvement is calculated as passive minus smart divided by passive times 100%. We use MATLAB and Simulink with 2DOF card model. This standard approach captures essential dynamic while being computationally efficient. The passive model uses spring and damper elements with fixed properties. The smart models add sensors, ICU, actuators, and PID controller that continuously monitors and adjusts. Parameters: Sprung mass 320 kg, in-sprung mass 40 kg, spring stiffness 22,000 Newton per meter, tire stiffness 192,000 Newton per meter, damping coefficient 1,500 Newton second per meter, road inputs 0.1 steps bump at 1.0 seconds, simulation time 5.0 seconds. This shows the quadruple car model with sprung mass, actuator, and sprung mass and sensor. It captures key dynamics. To summarize, we designed a rigorous, standards-based quantitative comparison using well-established simulation tools to systematically evaluate performance displacement differences. Thank you. I'll hand it over to Stephen for results.
Hello everyone, my name is Steven and I'm from the Republic of Congo and I am an aeronautical engineering student at Nanjing University of Aeronautics and Astronautics. I'm currently taking the academic writing course for our thesis project, Next Generation of Smart Suspension System for Automobiles. I serve as the deputy team leader. In this role, I help coordinate the project support communication among team members and ensure that our research progresses efficiently. I'm responsible for the results section of the project. My duties include conducting simulations and analyzing the collected data to evaluate the performance of smart suspension system. I generate graphs, tables, and all the visualization to present the result clearly and effectively. I also compare the performance of smart suspension system with conventional suspension system using objective performance indicators such as ride comfort, vehicle stability, and vibration reduction. In addition, I perform statistical analysis to ensure that our findings are accurate, reliable, and supported by evidence. The deliverables of my work include the result chapter, charts and figures illustrating system performance, detailed performance comparisons, and a comprehensive statistical analysis that highlight the effectiveness of smart suspension technology. Through this project, our team aims to contribute to the development of next generation intelligent suspension systems that improve vehicle safety, ride comfort, and other driving performance. Thank you for attention, and I'm looking forward to presenting our research. Thank you.
In summary, Mac chassis displacement reduced 61.5%, RMS displacement improved 73.8%, the peak acceleration reduced 60.4%, RMS acceleration improved 72.1%, the settling time improved 76.5%. Our core conclusion is smart suspension using real-time sensing to achieve both comfort and also control simultaneously. They don't trade one for the other. This is a fundamental breakthrough. Our limitations is the idealized actuator model, single disturbance. The PID control only, full validation pending. This suggests future work. Our future research is stochastic road profiles per ISO 8608, multiply speed and control strategy, hardware and loop validation, physics prototype testing. Our final statement: smart suspension technologies provide measurable, significant improvement, supporting transition from luxury feature and mainstream standard. In conclusion, our research validates that smart suspension systems represent the future. 60 to 75% improvement across all metrics demonstrate intelligent. Adaptive suspensions overcome limitations that plagued vehicle design for over a century. As sensors become cheaper and AI more sophisticated, smart suspension will become a standard on all vehicles, improving safety, comfortable, and also performance for everyone. Thank you for your attention. In this video, we briefly present the different types of academic assignments that you complete during this course. Our first, that we just showed in the video, our thesis. We focus on developing and presenting structured research and study based in our topic. As you can see in our research methodology, we use a quantitative research, and it's suitable because it is focused on collective analysis and on numerical data in order to compare performance in different situations. In this thesis, we have an introduction showing the background of automobiles, suspension systems, going a bit the problems, the conventional suspension, also doing the importance of the ride, like comfort, safety, and the vehicle stability. We introduce also the smart suspension system. In the we have the literature review, the convention, and also the suspension system. Comparing the both systems, we had the sensor and control systems and AI, introducing the smart suspension technologies, the sensors of a smart suspension system, electronic control of algorithm, a bit of industry 4.0 and intelligent systems, our methodology, and our results of data, and also a conclusion. Now, the academic report about the 3D printing and mechanical components manufacturing report, which are formal documents used to present information in a logical and organized way. These reports help to develop our ability to analyze and communicate technical content clearly. Third part, our essay about the importance of mental health for student development, where we develop structured arguments and discuss different ideas critically. This helped us improve our ability to express opinions in academic format. Now, I will briefly introduce the different types of reports we study in this course, as you can see in these slides. First, we go through some feasibility reports, which evaluate whether a project idea practical and worth doing. Also, the progress report, which show the current status of project, what's been completed so far. Incident report, which record unexpected events, what's happened and how they were handled. The investigative report, which uses analyze problem in detail and present findings and base evidence. These report types help improve our ability to organize information clearly and communicate professionally. We create resume, which is a professional document that summarizes our education, skills, and experience. It is an important tool for presenting ourselves in a clear and organized way. We wrote a cover letter, which use it to introduce ourselves when applying for a job or opportunity. We explain our motivation, strength, and interest in a specific position. We prepare a social media post where we learn how to adapt academic or professional content into short, clear, and engaging message suitable for online platforms. We work on a minute of meeting, which is introduction and record of discussion, decisions, and key points during the group meetings. This helped improve our teamwork and organization skills. Finally, through all these tasks, we develop important learning outcomes, including improved academic writing, better research skills, stronger teamwork, and a clearer communication in English. We have a short video for you.
The learning outcomes of this project include improving our research skills, learning how to structure an academic thesis properly, and gaining experience in presenting technical content in a professional way.
Hello everyone, the learning outcome of this thesis are to understand the key principles behind our topic, to develop structured academic writing skills, and to improve our ability to analyze and present engineering-related research in a clear and logic way. Thank you.
This thesis helped us develop key academic skills such as critical thinking, structured writing, and effective communication of engineering concepts based on research and analysis.
Hello everyone, through this thesis we aim to enhance our understanding of the subject, strengthen our academic writing abilities, and learn how to critically evaluate and organize technical information effectively.
As the deputy team leader, in this role, I help coordinate the project support, communication among team members, and ensure that our research progresses efficiently.
In this thesis project, we aim to combine research and academic writing skills to produce a structured and well-analyzed report, while also improving leadership, coordination, and presentation abilities within a group settings. We would also like to express our sincere acknowledgement to our teacher Wallace for his continuous guidance, support, and valuable feedback throughout this course, which has helped us to complete all the tasks. We also have a video for you.
Hello, Professor Wallace. As our academic writing course comes to an end, I would like to express my sincere gratitude for your guidance, patience, and encouragement throughout this semester. Your course has helped me improve not only my academic writing skills, but also my confidence in expressing my ideas clearly. The knowledge and feedback you share will continue to benefit me in my future studies and research. Thank you for your dedication and for inspiring us to become better writers. I truly appreciate it, all your support. Wishing you good health, happiness, and continued success. Thank you so much, Professor.
We would like to express our appreciation to our teacher Wallace for his continuous support and valuable advice during these projects, which help us develop our research and writing skills.
We would like to thank our teacher Wallace for his guidance and support throughout this academic writing course. His feedback has been very helpful in improving our thesis work. Thank you so much.
I would like to express our despite gratitude to our teacher Wallace for his continued guidance, support, and valuable feedback throughout this academic writing course and the thesis project.
We are grateful to our teacher Wallace for his encouragement and constructive feedback, which guided us in completing our thesis in a more structured and professional way.
We sincerely thank our teacher Wallace for his patience and guidance throughout the course. His suggestions were important in improving both our academic writing and pronunciation.
As the team leader of Group 14, I would like to say thank you so much for watching our video.
An excellent conclusion to today's lineup of presentations. Thank you, Group 14, for demonstrating how engineering innovation continues to improve everyday transportation. Judges may now begin their assessment, and audience members, please remember to vote for your favorite presentation.
What an excellent way to conclude our session of presentation. Let's give one more round of applause to Group 15 for sharing their outstanding research with us.
And with that, we have reached the end of our 17 presentations featuring groups 1 through 17. We'd like to extend our sincere appreciation to all the presenters for their hard work, dedication, and insightful research.
We also thank our respected professor, judges, and audience members for your time, attention, and continuous support throughout these presentations.
Oh no. Please stand by. Apologies.
Halima, can you take over? Thank you.
We finished?
Yeah, please you take over. He has some technical problem.
Experiencing technical issues.
Okay.
Yeah. Halim, yeah, please take over.
And with that, we have reached the end of okay, what is that? Okay. Sorry. And that brings us to the end of today's season. Thank you to you all the presenters for your incredible work. You have shown us ideas that inspire, challenge, and shape the future. A huge thank you also to the professor, organizers, and everyone who join us both in person and online. Don't forget to cast your vote and leave your comments on YouTube. Congratulations once again to all the present you have generally made New AA proud. I would like to congratulate every group that participates in today's academic writing presentation competition. Your dedication, creativity, and hard work have made today's presentation truly inspiring. I would now like to invite my classmates, Miss Malek and Mr. Zidan, to deliver a vote of thanks on behalf of Batch 2025. The stage is yours.
Good afternoon, honorable judges, respected faculty members, distinguished guests, and dear fellow participants. My name is Malek, and I have the privilege of being a closing host. Alongside my colleague Zidane, I am honored to deliver this vote of thanks on behalf of the batch of 2026. We extend our deepest gratitude to each one of you for taking time from your busy schedules to be part of this memorable occasion. As we gather here at the conclusion of this presentation competition, we find ourselves reflecting on the incredible journey we have shared today. What we have witnessed is nothing short of extraordinary, a showcase of intellect, creativity, and the transformative power of well-articulated ideas.
Each presentation delivered today represents far more than 10 or 15 minutes spent on stage. Behind every slide, every carefully chosen word, and every confident gesture lies weeks of research, countless revisions, and the courage to stand before an audience and share his own perspective. The range of subjects explored and sophistication of arguments presented have elevated the competition into a true celebration of academic growth and intellectual curiosity.
We would like to begin our acknowledgements by expressing our profound gratitude to our esteemed panel of judges. Your discerning evaluation, constructive critics, and encouraging words have provided invaluable guidance to all participants. The time and expertise you have invested in this competition have not only ensured its fairness but have also inspired us to strive for greater heights in our academic pursuits.
To the university administration and all supporting staff, we offer our sincere appreciation. Your unwavering dedication to creating an environment where learning flourishes and talents are nurtured has been instrumental in making events like this possible. The resources, facilities, and institutional support we enjoy have laid a strong foundation for our educational journey and personal development.
To our beloved faculty members and the dedicated organizing committee, we extend our heartfelt thanks. Your vision, meticulous planning, and tireless efforts have transformed this competition from a mere academic requirement into a platform for meaningful intellectual exchange. You have given us the opportunity to discover and refine skills we will carry with us for a lifetime.
Thank you, Ms. Malak and Mr. Zidan, for sharing our thoughts and emotions in your speech. We had a fantastic presentation competition and we enjoyed learning together this semester. We will work together again next semester with our improved versions.
Wait a moment. They have not finished yet. I think they dropped out. Give me a moment.
Oh, yes, sir.
Have elevated the competition into a true celebration of academic growth and intellectual curiosity.
We would like to begin our acknowledgements by expressing our profound gratitude to our esteemed panel of judges. Your discerning evaluation, constructive critics, and encouraging words have provided invaluable guidance to all participants. The time and expertise you have invested in this competition have not only ensured its fairness but have also inspired us to strive for greater heights in our academic pursuits.
To the university administration and all supporting staff, we offer our sincere appreciation. Your unwavering dedication to creating an environment where learning flourishes and talents are nurtured has been instrumental in making events like this possible. The resources, facilities, and institutional support we enjoy have laid a strong foundation for our educational journey and personal development.
To our beloved faculty members and the dedicated organizing committee, we extend our heartfelt thanks. Your vision, meticulous planning, and tireless efforts have transformed this competition from a mere academic requirement into a platform for meaningful intellectual exchange. You have given us the opportunity to discover and refine skills we will carry with us for a lifetime.
This competition has been a testament to the remarkable potential that emerges when inquisitive minds engage deeply with their subjects. Through this process, we have cultivated competencies that extend well beyond the podium. Skills such as analytical reasoning, persuasive communication, and the confidence to articulate complex ideas with clarity. These are attributes that will prove indispensable in our future academic endeavors and professional careers.
To our fellow competitors, you have been nothing short of inspiring. Your composure in the face of challenging questions, your mastery over diverse subject matter, and your ability to captivate and convince have raised the bar for excellence. The camaraderie and mutual encouragement we have shared throughout this experience have made this journey all the more meaningful and enriching.
As we depart from this venue today, we carry with us more than certificates and accolades. We take away the enhanced abilities to think critically, organize information logically, and present our viewpoints with conviction and grace. These are enduring gifts that will continue to serve us as we navigate the complexities of academic life and the professional world beyond.
In closing, we congratulate every participant for their outstanding contributions and command, the courage it took to step onto the stage. We thank all attendees, supporters, and well-wishers whose presence has added warmth and significance for this gathering. Let us continue to cherish and refine these essential communication skills that are the bedrock of academic and professional success.
We now kindly invite the event coordinator to guide us through the remaining proceedings of today's program. Wishing everyone a rejuvenated summer break filled with joy, relaxation, and wonderful memories. Thank you all for being here. Bye-bye.
Thank you, Miss Thank you, Miss Malak and Mr. Zidan, for sharing our thoughts and emotions in your speech. We had a fantastic presentation competition, and we enjoyed learning together this semester. We will work together in the next semester with our improved versions. We have now reached at the end of our NUAA presentation competition 2026. On behalf of all of batch 2025, I wish everyone a good and happy, safe summer vacation. Goodbye and see you all next semester. Please keep tuned in for the third session of the NUAA presentation competition 2026 tomorrow, same time.
Thank you, lovely host, for a wonderful job you have done. And this ends our second day of our presentation competition. And I'm sure that tomorrow we have lined up another 17 groups from over 122 countries who are participating in this event. So look forward. Have a good evening. Bye-bye. Thank you so
Bye-bye.
much. Bye-bye. See you.